Hello and welcome to the Earth Vault, your calm corner where curiosity drifts gently through the mysteries of our planet. Here we explore Earth's origins, its hidden phenomena, natural evolution, and even the tantalizing whispers of consciousness embedded in the ground beneath our feet. Tonight, our journey is slow, soft, and entirely yours to absorb. Have you ever wondered what if we were not the first civilization on Earth? Not the first thinkers, builders, or explorers? Long before pyramids, satellites, or bedtime science channels, what if another intelligent species rose, flourished, and then vanished without a trace? This isn't a tale of mythical continents or alien visitors. It's a question that lingers quietly in geology labs, anthropology debates, and the deep layers of our planet's history. Could a civilization have existed so long ago that even the rocks forgot it? Imagine, if you will, a world where forests stretched over unknown cities, rivers meandered past structures now gone, and mountains hid clues of intelligence that time has buried beneath layers of soil, stone, and ice. The traces would not be obvious. No skyscrapers, no smartphones, but subtle shifts in the land, unusual mineral deposits, and patterns that whisper stories to those who know how to listen. Our planet is a master of erasure, yet in its slow, deliberate cycles, might it have left hints for the observant eye? Scientists still debate the possibilities. The Silurian hypothesis, the search for ancient industrial footprints in the geological record. These ideas challenge our assumptions and invite wonder. As you settle in tonight, let your mind drift like tectonic plates over eons, tracing the invisible threads of what may have been, the echoes of a long-forgotten civilization intertwined with Earth itself. Before we dive deeper, take a moment to notice where you are. Are you listening from a quiet bedroom in New York, a dimly lit study in London, or perhaps a soft sofa in Sydney? Feel the subtle connection, across continents, across time zones, binding us in this shared moment of curiosity. Let your breath slow. Imagine the ground beneath you, solid yet ancient, holding secrets you can almost touch. Let your thoughts soften, letting the story settle into the rhythm of the planet itself. If you enjoy this kind of slow, meditative exploration, a like or subscription is a gentle way to help this quiet signal reach other curious minds. But there's no pressure, just a soft invitation to linger with us in the mysteries of Earth. Now dim the lights, settle back, and allow your mind to drift into the slow, mesmerizing pace of deep time. Tonight, we'll explore not just the traces of what might have come before us, but the very rhythm of the planet that holds those secrets, patiently, silently, for all who dare to wonder. If you close your eyes now, the noise of the present begins to fade. The streetlights dim, the glow of your phone dissolves, and what remains is a darkness as deep as the ocean floor. Somewhere, far below your feet, the planet is breathing, slowly, in rhythms you cannot hear but can almost feel. It exhales in the soft shifting of continents, inhales with the rising of mountains, and turns over in its sleep as the oceans crawl across its surface over millions of years. This is what scientists call deep time. Not just centuries, not just millennia, but stretches of time so vast that our own history, all of it, is just a thin thread in a tapestry that spans billions of years. If human civilization were a single candle flickering in a vast cathedral, deep time would be the cathedral itself, built not of stone, but of moments beyond counting. In deep time, mountains do not simply stand. They grow like coral reefs, grain by grain, and crumble again into the seas. Rivers carve canyons not in decades, but in silent patience over millions of sunrises and sunsets. Forests appear, thrive, vanish, and sometimes reappear in entirely different forms. Civilizations, if they existed, might not even leave a shadow for deep time to catch. The Earth's surface is a restless canvas, and the paint is constantly being scraped away and reapplied. It's almost impossible for us to imagine this. Our human clocks are tied to days, seasons, and years, to the beating of our own hearts. But in deep time, the planet's pulse is slower, heavier. It measures in ice ages, in volcanic arcs, in the slow dance of tectonic plates. The continents, Africa, Asia, Europe, the Americas, are just the latest arrangement in a long series of continental shuffles. 250 million years ago, all the land was one, Pangea. 250 million years from now, the land may merge again into another supercontinent. Here's a curious fact. The Earth's oldest rocks are found in western Greenland. The Akasta gneiss formed about 4.03 billion years ago. They have survived the grinding and recycling of the crust, preserved like the earliest pages of a very tattered book. If some trace of life, or something more complex, had been locked within them, it might still be there. But the truth is, most of the pages in Earth's book have been rewritten many times. Now imagine a single grain of sand on a quiet beach. Feels small, unimportant. But its journey through deep time could be extraordinary. Once it may have been part of a mountain towering higher than the Himalayas. Rain loosened it, rivers carried it, waves tumbled it smooth, and then, the shifting earth buried it deep, pressing it into sandstone for millions of years, before lifting it back to the surface to be worn down again. Civilizations could have risen and fallen during each step of that journey, without the grain noticing, or caring. This is why some scientists say that the Earth is not a kind archivist. It does not keep everything in tidy shelves for us to discover later. It's more like an artist constantly painting over its earlier work, not out of malice but because change is in its nature. The geologic record is a patchwork quilt with missing pieces, torn seams, and layers stitched on top of each other. Even the ocean floor, vast and seemingly eternal, is temporary. The oldest seafloor we have is about 200 million years old. Beyond that, all of it has been pulled back into the mantle by the process of subduction. If a coastal city had stood there in the Jurassic period, its ruins would now be molten rock beneath your feet. In the scale of deep time, oceans are not fixed. They open, close, and vanish like puddles drying in the sun. And yet, traces can survive. Fossilized forests, entire river systems preserved in stone, pollen grains trapped in lake mud. All of these are tiny time capsules. In Siberia's permafrost, scientists have found seeds from plants that grew 30,000 years ago, still able to germinate when thawed. If conditions are right, dry, cold, low in oxygen, matter can pause its decay almost indefinitely. But these conditions are rare, and deep time rarely grants them. There is also the matter of our tools, the way we measure time itself. We rely on radiometric dating, reading the slow decay of isotopes like uranium into lead, or potassium into argon, to count the age of rocks. We look at the flip-flopping patterns of Earth's magnetic field, recorded in volcanic rock like stripes in a geological barcode. But what we call precision is still coarse compared to the scale of billions of years. Whole eras blur together. And in those blurred spaces, mysteries can hide. Some scientists entertain the idea, purely as an exercise, that if an industrial civilization had existed tens of millions of years ago, its clearest legacy might not be buildings or bones, but changes in the chemistry of the planet. A spike in carbon isotopes, a thin layer of synthetic molecules, traces of rare earth elements arranged in patterns too neat for nature alone. The problem is, such patterns might also be explained by volcanic events, asteroid impacts, or other natural processes. The line between artifact and accident becomes very thin. Scientists still debate how confidently we could separate the two. I like to imagine deep time not as a straight timeline, but as a vast, shifting ocean. We are adrift on its surface, and every now and then, a wave pulls up something from the depths. A fossil, a mineral, a strange layer of rock. We examine it, try to place it, try to guess its story. Sometimes we succeed. Sometimes we can only admit that we do not know. There's a certain humility in that. The Earth has been here for 4.54 billion years. Modern humans, Homo sapiens, for about 300,000. Our recorded history? Barely 5,000. Against that backdrop we are brief. But brevity doesn't mean insignificance. Even small sparks can light up the dark, if only for a moment. So take a slow breath now. Inhale and exhale. Imagine you are not living in 2025, but drifting above the Earth in a slow orbit through billions of years. You watch the continents move like puzzle pieces on a living table. You see ice sheets grow and melt, oceans open and close, forests bloom and burn. You see cities rise, not just ours, and fall back into dust. And you realize something both humbling and freeing. In deep time, nothing lasts forever, but nothing is truly gone either. Everything leaves some kind of trace, even if it is only the faintest shadow in the rocks. And that is where we will begin our search. Beneath the open sky, the world breathes in ways we cannot always see. You stand on the edge of a cliff, the wind brushing past you in a slow, deliberate motion, and for a moment you imagine it as the hand of time itself, running its invisible fingers across the surface of the earth. That wind has touched mountain peaks and ocean waves, has slipped between grains of sand, and has curled into the hollows of caves. It has whispered against the stones of old cities, and then, with the same patient ease, carried away a fragment of them, one grain at a time. This is how time erases, not with sudden violence, but with a steady, unblinking gaze year after year after year. Civilizations like ours think in centuries, sometimes in millennia, but the earth thinks in eons. And in the eons there is no hurry. The forces that change the face of the planet move in rhythms so slow they are almost invisible, yet they never stop. Erosion begins in ways that feel almost tender. The sun warms a rock in the afternoon, the night cools it, and the tiny expansions and contractions create hairline fractures. Rain seeps in, freezes in the cold, expands and slowly pries the rock apart. Each droplet of water carries with it a fragment of the stone, so small it would take thousands to cover the tip of your finger. But over thousands of years this becomes canyons. Over millions, mountains shrink into rolling hills. It is hard to imagine a process so quiet being so powerful. Yet this is the true engine of change, the whisper, not the shout. Wind takes over where water leaves off. In deserts, it sculpts stone into arches and pillars, carrying away grains in endless migration. Entire civilizations have watched their buildings wear down under the constant abrasion of airborne dust. What seems solid to us is only temporarily so. To the wind, it is already halfway to sand. Even the most carefully carved monuments will soften, blur, and lose their sharp lines. We can try to preserve them, but we are only buying time in a game we cannot win. Sedimentation is the flip side of erosion, the place where what is taken away finds a new home. The fragments of mountains and cities settle in river deltas, in lake beds, in the quiet places at the bottom of the sea. Layer by layer, they form archives that will one day be stone again, compressing under their own weight until they are bound together in new forms. You could stand on a plain of sandstone and not know that beneath your feet lies the compressed memory of a vanished coastline, or the dust of a city ground so fine you would not recognize it. Somewhere in that rock might be a sliver of pottery, a trace of brick, or the mineral ghosts of human bones. But if you looked for them without knowing exactly where, they would be lost to you. Nature does not preserve for our benefit. It only moves forward in the dance of transformation. Far deeper down, in the restless engine room of the earth, the plates of the crust shift and slide. Where one plate meets another, it may be forced downward in a slow, unstoppable plunge, a process called subduction. In those places, the surface of the planet is consumed, drawn into the mantle where rock becomes molten, where the traces of everything it carried, mountains, forests, cities, are melted beyond recognition. This is not destruction in the human sense, it is recycling on a planetary scale. What disappears in one place will reappear elsewhere, perhaps as a volcanic island or a ridge at the bottom of the ocean. But what was once a wall, a road, or a temple is gone forever, its atoms scattered into the magma, mixed into something unnameable. It is strange to think that the surface of the earth we know is, in a geological sense, young. Most of what we walk on has been remade in the last few 100 million years, recycled from older crust that no longer exists. There are places like the ocean floor where no rock older than 200 million years survives, because the relentless conveyor belt of plate tectonics pulls it under and creates it anew. In contrast, there are ancient cores of continental crust, cratons, that have persisted for billions of years, holding stones that remember the earliest days of the planet. But even these are worn by wind and water, slowly surrendering their sharp edges, slowly giving themselves back to the cycle. Scientists still debate exactly how much of human civilization will leave a trace in the geological record after millions of years. Some say there will be chemical fingerprints, unusual concentrations of certain metals, plastics transformed into strange new minerals, isotopes from nuclear activity. Others suggest that even these will be diluted and erased, smeared out in the endless churn of rock and sediment. If another species far in the future were to look for us, they might find nothing more than a faint line in the stone, a thin horizon marking a momentary flare of activity before it was folded into the deep. It is comforting in a way to see ourselves from this vantage point. The tallest skyscrapers, the largest dams, the most ambitious monuments, all will one day be as gone as the wooden huts of the earliest villages. The earth will smooth over our presence as the tide smooths the marks of footsteps on a beach. And yet, within our brief time, we make marks that matter to us. We carve our names, build our roads, tell our stories. We know they will not last forever, and still we make them. Perhaps it is because we are not trying to speak to the far future, but to each other, here and now. Imagine a city left untouched for 1,000 years. Plants would break through pavement, roots would pry apart walls, rain would wash pigments from signs and paintings. In a few thousand years more, the buildings would collapse, leaving mounds of rubble where avenues once lay. Erosion would carry those fragments away, distributing them into streams and rivers, grinding them finer and finer. In tens of thousands of years, the outlines of the city would be invisible on the surface. In 1,000,000 years, only careful excavation might reveal a few scattered hints, and even those would be fragile. Give it 10 million years, and subduction or metamorphism could erase them entirely. Somewhere in the ocean, volcanic islands rise from the sea, build themselves into lush paradises, and then, under the same slow forces, sink back beneath the waves. Coral reefs grow around their shores, then die and turn to limestone. Storms grind that limestone into sand. The sand becomes part of a new beach somewhere else. The eraser does not act in one place only, it moves everywhere all the time, patient and thorough. Even the coldest, most remote places are not safe from change. In the polar regions, glaciers move like rivers of ice, grinding the bedrock beneath them, carrying away mountains in their frozen grip. As they melt and retreat, they leave behind smooth valleys and scattered boulders, the debris of their slow journey. In deserts, where rain is rare, the temperature swings between day and night crack the rocks just the same, and wind scours the surfaces clean. In the tropics, humidity and heat create chemical weathering that can turn stone to clay in just a few thousand years. Every climate has its own style of erasure. There are, in rare cases, moments when the earth seems to preserve rather than destroy. Volcanic ash can bury a city in hours, sealing it away from air and water, preserving walls and even food on tables. Peat bogs can encase wooden structures and bodies for millennia. Tar pits can hold bones in their sticky embrace. But these are exceptions, and even they are temporary on the grand scale. The ash will eventually weather, the peat will dry and erode, the tar will crack and crumble. Time reclaims everything. Perhaps the strangest thought is that, in the very long run, even the continents themselves will be rearranged. The land we know will merge, split, drift across the globe. Mountains will rise where there are plains. Oceans will open where there are mountains. Any trace of us tied to the current map will become meaningless. You could stand on the shore of some future continent, knowing that beneath your feet is the pulverized, melted, and remade dust of a civilization long gone, and never suspected. This is not a tragedy in the eyes of the planet. The Earth is not sentimental. It is a place of continuous change, of cycles that are beautiful precisely because they are endless. To watch a rock crumble, to see a cliff retreat under the push of waves, is to watch the breathing of the world. It is slow, but it is certain. In that certainty there is a kind of peace. Nothing is fixed, and yet everything is part of the same story, written not in ink but in layers of stone and sand and sea. Imagine drifting through time, a journey not measured in days or years, but in millions, stretching backward across the deep and silent oceans of history. You glide above layers of rock, each one a page in the Earth's vast diary, written in sediment, minerals, and fossilized whispers. The Earth's memory is long but selective. Some moments are vivid, preserved in amber or ash, in calcium or silica, while others are erased almost as if they had never existed. It is here, in the quietest corners of geological record, that a question emerges, one that is as delicate as it is audacious. Have there been civilizations before us, and if so, could any trace of them have survived the slow, inexorable sweep of time? This is the essence of the Silurian hypothesis, a term whispered in the halls of speculative geology, a question that teases the edge of what we know and what we can only imagine. The Silurian hypothesis does not suggest that we are the first species to walk the Earth, but rather asks whether any prior industrial civilization might have left detectable fingerprints hidden in deep time. These fingerprints are not monuments or cities, for those would crumble and dissolve long before our distant future archaeologists could see them. Instead, the search is subtle, scientific, almost meditative. Researchers propose looking for anomalies in the geological record, unusual concentrations of isotopes, strange distributions of metals like aluminum or platinum, layers of soot from fires that might never have been large enough to scar the sky as we know it, or chemical signatures in sedimentary rocks that hint at large-scale industrial processes. These are whispers of activity, delicate traces that require patience to interpret, and humility to imagine. Drifting across the globe in this thought experiment, you might imagine the remnants of forests turned to charcoal, or the faint shimmer of plastics transformed into rock-like polymers over millions of years. Perhaps there are mineral traces of smelting or traces of nuclear isotopes that linger, yet diluted and fragmented, almost invisible to the naked eye. The Earth has a way of absorbing our ambition, of converting our constructs back into the soil, water, and air that compose the endless cycles of the planet. A city, a road, an entire industrial complex could be ground into sediment, washed away, compressed into shale, or pushed into the mantle, leaving only the subtlest anomaly in the chemical record. The very idea that we might find evidence is both tantalizing and humbling. As you imagine standing on a cliff, looking at a landscape that seems timeless, consider that beneath the surface, there may be layers representing moments of intense change. Moments where something, somewhere, altered the chemistry of the oceans or the distribution of carbon and nitrogen, or the very structure of sediments. Scientists who entertain the Silurian hypothesis often turn to the fossil record, to ocean cores, to deep sedimentary basins. They measure carbon isotopes, noting fluctuations that could indicate massive combustion, shifts in atmospheric composition, or widespread environmental alteration. They look for layers of minerals that do not correspond to natural processes alone, anomalies that raise the possibility, however remote, that something intelligent intervened. Even as you imagine this, the Earth continues its patient work. Rain falls, winds blow, glaciers creep across valleys, and tectonic plates drift, carrying sediments and rocks into molten depths. In this constant motion, even the most carefully preserved signs of a civilization are at risk of being erased, metamorphosed, or buried beyond recognition. Yet there is beauty in this impermanence. Each layer of sediment tells multiple stories at once. The rise and fall of species, the cycles of climate, the chemical rhythms of oceans, and perhaps, just perhaps, the faint echoes of a civilization long gone. In this meditation, the Earth becomes both library and laboratory, a space where curiosity and imagination coexist with rigor and evidence. Oddities in the geological record provide both hints and cautionary tales. For example, microplastics have been found in sediment layers, preserved long after their initial creation, signaling the power of human activity to leave indelible marks. Similarly, high concentrations of metals such as nickel, platinum, and chromium can indicate intense industrial or natural processes. Some researchers have even speculated that if a previous industrial civilization had existed, the chemical signature of their activities might be visible in ways similar to ours, yet distorted by time and geology. The idea that a global industrial footprint could vanish almost entirely, leaving only subtle isotopic hints, challenges our understanding of permanence and legacy. It forces the mind to reconcile ambition with transience, achievement with erasure. As you drift further into this meditation, consider the power of sediment cores taken from the ocean floor. These cylinders of compressed time offer snapshots of the past, layer by layer, like tree rings for the planet itself. Within them are traces of microscopic life, pollen grains, soot, and chemical markers, all recorded in sequences that span millions of years. In some layers, anomalies appear, tiny blips of carbon isotope ratios that cannot yet be fully explained. Could these be the fingerprints of a pre-human civilization, or merely the result of volcanic eruptions, meteor impacts, or natural climate variation? Scientists remain divided. Some argue that these fluctuations are entirely natural, products of processes we only partially understand. Others maintain that while extraordinary claims require extraordinary evidence, it is not impossible that subtle, non-obvious markers of intelligent activity might exist, hidden in plain geological sight. The mind, when allowed to wander in this slow and expansive way, begins to perceive the scale of deep time differently. Millions of years stretch like soft, infinite waves, carrying with them continents, oceans, mountains, and species that rise and fall in succession. Within this vastness, a civilization, even a highly industrious one, might flicker like a candle in a cavern, illuminating briefly before it is extinguished by the slow, inevitable movements of the earth itself. The realization is both sobering and strangely comforting. What we create, no matter how monumental, is always temporary, a delicate brushstroke on a canvas that spans billions of years. Imagine then that we could glimpse fragments of such a civilization, not as towering buildings or sprawling metropolises, but as chemical anomalies, isotopic irregularities, or minute traces in sedimentary layers. Picture scientists hundreds of millions of years in the future, coring the ocean floor or drilling through ancient rock, uncovering evidence that challenges everything they know about the past. Perhaps they would find microplastics fossilized in shale, isotopic ratios suggesting large-scale combustion, or traces of metals inconsistent with natural processes. These signs would be subtle, requiring careful interpretation, patience, and imagination. And yet, even in the most meticulous analyses, the story would remain incomplete, tantalizingly suggestive but never fully confirmed. Even as this speculative journey unfolds, the earth continues its quiet erasure. Rivers carve valleys, glaciers smooth mountains, and wind polishes rock into abstract sculptures. Sediments accumulate, subduction draws continental edges into the molten mantle, and the planet recycles itself with unending patience. In this rhythm, even the most carefully constructed civilizations are at risk of vanishing entirely. Our own cities, monuments, and industrial sites are temporary intrusions into a landscape that thinks in eons, not centuries. Yet in this impermanence, there is a kind of grace. The earth is neither cruel nor forgetful, simply persistent, moving forward in cycles of creation and destruction, preservation and erasure. One of the most compelling aspects of the Silurian hypothesis is that it invites a kind of meditative attention to what is already present. By studying carbon isotopes, ocean sediments, and fossil records, scientists must cultivate patience and imagination in equal measure. Every layer of shale, every anomaly in the chemical record, becomes a potential story. Every piece of evidence, no matter how minute, is a conversation between the past and the present, a dialogue that unfolds over millions of years. We learn to listen in the way one listens to a faint melody in the wind, subtle and beautiful, carrying messages we may never fully comprehend. Oddly, some of the most remarkable evidence can be found in the most ordinary places. Pollen grains trapped in sediment, microscopic shells, and tiny particles of soot can all serve as hints of activity long forgotten. Even the humble clay layer beneath a plain could hold a signature of ancient industry, a momentary flare of human, or perhaps pre-human, ingenuity preserved in silence. It is a humbling reminder that the Earth's memory is selective, fragile, and enigmatic, and that what survives is often not the grandest structure but the smallest, most persistent whisper. And yet the debate continues. Scientists still argue about the plausibility of a pre-human industrial civilization. Some insist that any such civilization would inevitably leave unmistakable traces in the geological record, traces that should be detectable even millions of years later. Others contend that natural processes, erosion, sedimentation, chemical alteration, subduction, would erase nearly everything, leaving behind only the faintest chemical anomalies, easy to misinterpret or overlook. The Silurian hypothesis does not provide answers. It offers questions, a meditation on possibility and impermanence. As you imagine these layers of rock, time folding upon itself, the concept of civilization itself begins to stretch. Civilization is no longer only stone and metal, roads and cities. It becomes patterns in chemistry, anomalies in isotopes, whispers in sediments. It is ephemeral, fleeting, and yet, for a brief moment, visible to those who know where and how to look. We begin to perceive civilization not as a monument to permanence, but as a brief, glowing pulse within the vast, quiet, and patient heartbeat of the earth. In this contemplation you can close your eyes, breathe slowly, and let your mind drift through the deep layers of time. Picture yourself above an ancient plain, thousands of meters below the surface, where sediments are being laid down in soft, endless layers. Imagine the faintest traces of fire, the invisible shimmer of metals, the compressed whispers of a vanished city. Feel the slow passage of millions of years as the continents drift, rivers carve, glaciers grind, and plates slide, carrying with them everything we call history. And in that slowness, realize that the earth is always both storyteller and editor, preserving some memories, erasing others, and folding the ephemeral into the eternal rhythm of change. The Silurian question is not simply about proving a prior civilization existed. It is an invitation to observe deeply, to consider the patience of the planet, the fragility of legacy, and the humbling perspective that everything we build is temporary in the sweep of geological time. It asks us to imagine a world where footprints can disappear without a trace, where even the greatest achievements might become subtle chemical curiosities millions of years from now, and where the earth continues, serene and indifferent, composing its vast, ongoing story. You may take a moment to drift with this thought, breathing in the slow, patient rhythm of deep time. Feel the rivers flowing, the glaciers moving, the continents shifting beneath you. Let the earth's patient erasure calm you, remind you of the quiet persistence of change, and carry you gently into the next layer of this journey, where science and imagination intertwine, and the echoes of possibility stretch infinitely in every direction. In the hush of deep time, even the smallest particle can speak volumes. Drift slowly above a landscape that seems both familiar and strange, where forests once thrived and oceans whispered across shores that no longer exist. Every grain of sand, every layer of sediment, every speck of ash carries a story. Some of these stories are obvious: a fossilized shell, a fossilized leaf, but others are subtle, encoded in the very chemistry of the earth, like tiny fingerprints left by forces both natural and perhaps intelligent. Imagine carbon, the building block of life, dancing invisibly through the oceans and atmosphere, moving through plants, animals, and soils, cycling in a rhythm that has persisted for billions of years. The ratios of its isotopes, different forms with the same number of protons but varying neutrons, carry delicate information about the past. Carbon-12, carbon-13, carbon-14, each has a story to tell. When humans burn fossil fuels, we change the balance of these isotopes in the atmosphere. But if another civilization had existed long before our own, could their use of energy, their fires, their industrial activity, have left similar isotopic whispers in rocks and sediments? These are the questions that bring the Silurian hypothesis into sharper focus. The beauty of isotopic evidence is in its quiet persistence. Unlike cities of stone or monuments of metal, isotopes are invisible to the eye, yet they endure through the endless churn of wind, water, and tectonics. Carbon flows into sediments, becomes trapped, and preserves the chemical memory of a moment in time. Think of it as the earth keeping a diary, written in letters invisible to our senses, readable only with patient analysis and sensitive instruments. These anomalies may appear as small, almost imperceptible deviations from natural patterns, a subtle rise in a particular isotope, a deviation that hints at a pulse of energy, a transformation of matter that should not have been there. Microplastics, too, are messages in a bottle cast across the deep ocean of time. You may imagine tiny particles, smaller than a grain of sand, floating in sediments, clinging to layers that accumulate slowly over millennia. Plastics are resilient, resistant to decomposition, and can endure long after wood, stone, and metal have returned to dust. A future scientist drilling into the sediment might detect these particles, a faint signal of industrial activity, preserved in their miniature persistence. Even today we see microplastics embedded in soils, in riverbeds, and in deep ocean cores, a testimony to the reach of human industry, and perhaps, a hint of what might survive if civilizations come and go over geological time. The rare earth elements, lanthanides, scandium, yttrium, offer another layer of subtlety. These elements are distributed unevenly across the planet's crust, and industrial activity can concentrate them in ways that nature rarely does on its own. Smelting, mining, refining, each of these processes leaves chemical anomalies and sediments. Picture a river delta, where layers of mud and silt accumulate over thousands of years. Buried within those layers, a slightly higher concentration of rare earth metals could be a whisper of technology, a faint fingerprint of intelligent manipulation, faint but detectable if one knows how to read it. As the earth breathes, as oceans shift, as winds sweep across deserts and mountains, these subtle traces are moved, diluted, and sometimes destroyed. Yet some persist, like small echoes that travel across time, ready to be found by patient observers. There is a rhythm here, a quiet poetry, in which the planet records and recycles, allowing only the most persistent messages to survive. And within this rhythm, the imagination can wander, tracing the faint outlines of activity that might have existed millions of years before our own. Consider how ordinary processes can create extraordinary signals. Fires in forests release carbon into the atmosphere. Massive volcanic eruptions send dust and ash into the sky. Distinguishing between natural and intelligent causes is a challenge that scientists embrace with both rigor and humility. It is possible to measure chemical anomalies and attribute them to extraordinary energy consumption, but nature always offers alternative explanations. Scientists still debate how confidently one could identify a long-lost industrial civilization purely from isotopic and chemical signals. The debate is ongoing, a gentle reminder that evidence is not always straightforward, and that imagination must walk hand in hand with skepticism. Now, picture floating through a landscape once occupied by life, long before humans carved cities into its surface. Beneath you, sediments accumulate slowly, layer upon layer, each a record of climate, life, and chemistry. Carbon isotopes shift subtly, rare metals concentrate in ways that defy purely natural expectation, and microplastic-like residues might linger, tiny particles that have outlived forests, rivers, and even mountains. These are the whispers of activity, the soft, enduring signatures that time cannot entirely erase. The imagination begins to perceive civilization not as stone and steel alone, but as chemical interactions, as subtle perturbations in the balance of the planet. You might see a valley filled with deposits that glow faintly under imagined instruments, revealing the faint fingerprint of intelligence. Each layer is a memory, compressed and protected in sedimentary stone, holding fragments of activity that may have occurred hundreds of millions of years ago. In this meditation, the Earth itself becomes an archive, a vast and patient library in which the quietest of marks can persist, awaiting discovery. Even ordinary particles carry profound significance. Clay particles trap trace chemicals. Fine sediments settle in calm waters and record variations in oxygen and carbon. Minerals formed under unusual conditions might hint at high-temperature smelting or chemical reactions induced by conscious beings. To observe these patterns is to enter into a dialogue with the planet itself, to listen to the subtle hum of geological processes as they intertwine with hypothetical activity. There is a poetry in this interplay between nature and potential intelligence, a lullaby of atoms and isotopes, of dust and sediment, that invites contemplation and gentle awe. Imagine drifting through an ancient seabed, where layers of sediment ripple like a slow-moving river frozen in stone. Each grain of sand carries a whisper of time. Carbon ratios hint at pulses of energy, layers of dust record atmospheric events, and rare metals concentrate as if guided by unseen hands. These are not monuments but footprints, delicate and almost imperceptible, testifying to activity that may have shaped environments, altered chemistry, and left its subtle mark on the planet. It is an intricate, quiet story told in whispers of atoms, particles, and isotopes. A story the mind can linger over, inhaling slowly, feeling the passage of deep time with every breath. Even as these whispers persist, the earth continues its gentle erasure. Sediments shift under rivers and oceans, weathering breaks down exposed rock, and tectonic plates slowly grind continents together and apart. The anomalies may be diluted, hidden, or transformed, Yet a patient observer, attuned to the faint language of atoms and particles, may detect them. And in that detection there is wonder. There is the recognition that even in the absence of grand structures, chemical signatures can testify to possibility, to the fleeting dance of civilizations long gone. As you let your mind drift over these imagined landscapes, breathing slowly, picture the slow accumulation of sediments, the quiet shifts in isotopic ratios, the subtle presence of microplastics and rare earth metals. Feel the patient rhythm of the planet, which records and transforms, preserves and erases. Contemplate the impermanence of all human constructs, and the enduring beauty of subtle traces that may survive in silence for millions of years. These whispers of carbon and dust, delicate yet persistent, are a meditation on time, nature, and the fragile persistence of intelligence on a planet that moves at the pace of deep geological rhythms. In the stillness of early night, let your mind drift above a vast, unseen landscape, one that stretches not only across continents, but across the invisible networks of life itself. Civilization, as we have long defined it, has been confined to cities, monuments, texts, and governments, a human-centric tapestry of achievement and ambition. Yet, when viewed from the vantage of deep time and broad imagination, this definition begins to seem narrow, almost fragile. Could intelligence, organization, and enduring impact exist beyond stone and steel? Could a civilization, in a sense, manifest itself not through towering structures but through the complex choreography of life and environment? Imagine a forest. Not a quiet, static grove, but a dynamic, breathing system, where trees exchange nutrients through fungal networks, where birds, insects, and mammals form intricate relationships, and where water, sunlight, and soil participate in an endless dance of energy and growth. Here, life itself demonstrates organizational complexity, a distributed intelligence that monitors, adapts, and evolves. The forest is a civilization of a different kind, one that predates humans and may outlast them. In its slow rhythm, the forest writes its history not in monuments, but in patterns, in chemical gradients, in the flow of energy through countless living forms. Ecologists studying such systems have often noted that complexity can emerge without conscious planning. Yet, if we expand our definition of civilization to include patterns of intelligence, organization, and sustained influence over an environment, these networks might qualify. Consider coral reefs, where tiny polyps collectively construct enormous calcium carbonate cities, each contributing to a structure that can persist for millennia. Here is a civilization of minuscule architects, whose impact is global and enduring, shaping ocean chemistry, sedimentation, and biodiversity. The reef is both laboratory and monument, a record of ecological intelligence and collective effort, and it is entirely possible to imagine similar non-human intelligences in Earth's deep past, whose legacies are recorded subtly in sediments, isotopes, or anomalous chemical layers. As you drift further over imagined landscapes, envision grasslands where herbivores, predators, fungi, and bacteria maintain balance in a delicate web. Each species acts according to instinct, yet the cumulative effect is a regulated system, remarkably stable over thousands or millions of years. The soil itself retains memory. Layers of nutrients, carbon, and microorganisms encode histories of climate, fire, and population cycles. Even here, subtle patterns could be interpreted as evidence of intelligence, a civilization of life rather than humans, a civilization whose artifacts are ephemeral chemical signatures, population rhythms, and ecological structures. Scientists have begun to explore such concepts in the study of Earth's complex systems, noting that intelligence need not manifest solely through technology or writing. Some have proposed that patterns in ecosystem engineering, like beaver dams, termite mounds, or engineered wetlands, demonstrate purposeful environmental manipulation at scales meaningful enough to endure, raising questions about how we identify civilization itself. Now, imagine the possibilities stretched further, to organisms and systems we do not typically consider intelligent. Fungi that span kilometers underground, communicating chemically across networks of roots and soil, redistributing nutrients where needed. Microbes that alter geochemistry, fixing nitrogen or metabolizing minerals in ways that reshape soil composition over millennia. Even the collective behaviors of insect colonies, ants, bees, or termites, can leave a mark on the landscape, shaping vegetation patterns, soil structure, and the course of water. Each of these is a system, a coordinated entity with long-term influence, whose presence could, in principle, leave a subtle imprint in the geological record. The Earth, in these instances, becomes both cradle and chronicler, recording activity not in stone monuments but in chemical, structural, and ecological footprints that may survive millions of years. If we stretch our imagination yet further, we can consider civilizations that were entirely non-material, forms of intelligence that left no physical constructions, no cities, no metals, yet altered environments subtly, influencing climate, biogeochemical cycles, or ecosystem composition. Perhaps these civilizations manipulated nutrient flows, selectively propagated certain species, or even engineered microbial communities in ways that persisted as chemical or isotopic anomalies. When we study carbon isotopes, rare earth metals, or sedimentary layers in deep time, might we detect patterns that suggest purposeful activity, subtle but real, imprinted in Earth's slow-moving canvas? Scientists remain cautious. Some argue that it is almost impossible to differentiate these patterns from natural processes. Others contend that careful analysis of anomalies in isotopes, sediments, and fossil records may offer hints. The question remains open, inviting speculation as well as rigorous investigation. Let your mind wander across imagined landscapes of deserts, wetlands, mountains, and deep oceans. In each environment, life forms networks of interdependence that shape the Earth in profound ways. Beavers construct dams, transforming waterways. Mangroves stabilize coastlines. Termites aerate soil and redistribute nutrients. Microbes mediate mineral formation, occasionally leaving deposits of metals or isotopes that could be detected millions of years later. Each action, seemingly small, contributes to a broader system of influence and persistence. Viewed across eons, such systems could constitute a civilization not by human standards, but by the standards of impact, coordination, and endurance. Perhaps in the distant past, on Earth or elsewhere, civilizations were entirely ecological, leaving no grand monuments but altering the planet in ways subtle yet detectable. Sediments may hold anomalies in carbon ratios, unusual concentrations of trace metals, or evidence of rapid environmental shifts that hint at purposeful intervention. Microplastics might not exist, but perhaps other resilient chemical traces, biogenic or anthropogenic, remain hidden in layers of shale or limestone. The imagination allows us to picture these possibilities, to explore the idea that civilization need not be built of brick or steel, but of patterns, networks, and persistent influence over ecosystems. Even today, humans often overlook the complexity and intelligence embedded in ecosystems. It is easy to regard forests, coral reefs, or grasslands as passive or merely functional. Yet these systems demonstrate feedback loops, resilience, and coordinated processes that maintain stability over millennia. Each nutrient cycle, each symbiotic relationship, each predator-prey interaction is a small act in the choreography of a living, persistent, and self-regulating system. If intelligence is measured not solely by tool use or language but by the capacity to shape environments intentionally or adaptively, then our conception of civilization broadens dramatically. As you drift slowly above imagined ancient landscapes, picture intricate mosaics of life, where influence is measured not in monuments but in lasting effects on Earth's chemistry, hydrology, and biological networks. Consider that traces of such non-material civilizations, if they existed in deep time, might be hidden in isotopic anomalies, unusual sedimentary structures, or chemical irregularities. Perhaps tiny shifts in ocean chemistry or soil composition could hint at intelligent management of resources, climate, or species composition, leaving signatures that endure long after the entities themselves vanish. Scientists continue to debate these possibilities, emphasizing that direct evidence is lacking, but that the patterns and principles are worth exploring, encouraging both imagination and rigor. Imagine a forest where each tree, fungus, and organism contributes to a subtle, collective intelligence. Rivers are shaped not only by geology but by the living networks they nourish. Soils retain memory of past activity. Clouds form, rainfall follows, and patterns of growth and decay repeat in rhythms both predictable and astonishingly complex. Civilization, in this broader sense, is not human exclusive. It is the orchestration of living and non-living processes to maintain and shape environments over time. In this view, the Earth is alive with civilizations that leave no towers, but whose footprints are written in atoms, isotopes, and sedimentary patterns. Through this meditation, breathe slowly, imagining the pulse of life, the slow passage of time, and the delicate orchestration of ecosystems. Picture influence as invisible threads weaving through landscapes, leaving subtle markers that endure beyond the lifespan of individual organisms. Civilization becomes a pattern in motion, a map not of cities but of energy, matter, and life itself. And in that map, the Earth's vast, patient narrative unfolds, reminding us that intelligence and complexity manifest in ways both tangible and elusive, visible and hidden, monumental and minuscule. In this reflection, the question emerges gently: what, then, is civilization? Is it the monuments we build or the patterns we leave in the world, tangible or chemical, physical or ecological? Could these subtle, long-lasting imprints be what remains after the passage of millions of years, after tectonics, erosion, and the patient erasure of time? Scientists continue to explore, to debate, to measure and imagine. There is no single answer, only the invitation to perceive the Earth as a living archive, to recognize intelligence and influence in forms both expected and surprising, and to wonder at the delicate persistence of patterns that may endure far longer than any human construction. Breathe slowly and let your imagination wander through these intricate networks, across forests, oceans, deserts, and mountains. Feel the pulse of life and the slow rhythm of Earth's chemistry. Sense that civilization may exist beyond stone and steel, in the subtle orchestration of living systems, in patterns preserved in soil, water, and air, waiting quietly to be discovered. The world is alive with complexity, and in the deep, patient movements of ecosystems, you may glimpse a form of civilization that transcends human perception, stretching across time and space, ephemeral yet enduring, faint yet undeniable. In the quiet solitude of the planet's memory, stones speak. Drift gently above landscapes both ancient and imagined, where mountains rise like the spine of a sleeping giant, and valleys fold beneath like the pages of a vast, unread book. Each rock, each layer, each hidden crevice contains stories waiting to be deciphered, a language written not in words but in mineral grains, fossilized remnants, and the very structure of the Earth itself. As we float over cliffs, riverbeds, and ancient quarries, the mind begins to perceive time as layered, compressed, and sedimented within these geological archives. Consider fossils, those remarkable capsules of memory. Bones, shells, and impressions preserved in stone offer glimpses of life that once walked, swam, or grew across the surface of Earth. Each fossil is a record of form, behavior, and environment, an echo of the living world captured in mineralized permanence. Imagine the slow replacement of organic material by minerals over millennia, molecules crystallizing to retain shape and detail, like a careful sculptor transforming fleeting life into enduring stone. In deep time, such fossilization is selective, preserving some stories while erasing others, a reminder that memory is always partial, biased, and mediated by the laws of chemistry and physics. Now envision ancient quarries, sites where stone was extracted to build monuments, roads, or shelters. Even in the absence of inscriptions or ruins, the very act of quarrying reshapes landscapes, leaving patterns in the bedrock and soil that persist long after structures vanish. Straight cuts, tool marks, and disrupted strata speak silently of purposeful activity. Across eons, these sites may be buried by sediment, overgrown by forests, or submerged under oceans, yet the geological record retains their faint signature. Rocks, in their patient persistence, both preserve and conceal. They are archivists and erasers, holding evidence in their core while obscuring it from casual view. As we drift across imagined terrains, picture subterranean structures, caves, tunnels, underground chambers, shaped by both natural processes and intelligent hands. Lava tubes, karst formations, or mined passageways all offer unique environments for preservation. Within these spaces, the absence of sunlight, the slow accumulation of sediment, and the stable microclimate can protect artifacts, fossils, or chemical anomalies for millions of years. Yet even here, time is never idle. Water percolates, minerals deposit, rock slowly shifts. Information is encoded, transformed, and sometimes lost, a delicate balance between preservation and decay. In certain locations, rocks act as extraordinary time capsules. Sedimentary layers accumulate in calm waters, forming shales, limestones, and mudstones that embed remains of organisms, debris, and chemical traces. Each stratum represents a moment, a whisper of environmental conditions, climate, and possible activity. Tiny fossils within these layers, microfossils, pollen grains, or microscopic shells, can reveal ecosystems, biodiversity, and climate fluctuations. Sometimes, unusual isotopic ratios or trace metals appear, faint echoes of energy use or environmental manipulation that may suggest intelligent intervention. Scientists still debate how confidently such signals can be attributed to past civilizations, emphasizing both the intrigue and the uncertainty of interpreting the deep record. Consider also the subtle effects of human-like activity on the rock itself. Quarrying leaves scars, mining alters mineral distribution, construction compacts sediments, pathways and canals divert water, creating erosion patterns. Even if structures decay completely, traces remain embedded in stone. Imagine a meandering river cutting through an ancient city, carrying away surface remnants but leaving disturbed strata behind, subtle deviations in grain size or composition marking places once inhabited. Geological processes both erase and encode, like a painter who blends colors into a larger canvas while leaving behind invisible brushstrokes discernible only upon careful study. Floating across imagined landscapes, you might see cliff faces etched with horizontal layers of sediment, interrupted here and there by strange intrusions, perhaps dikes, faults, or tunnels. Each irregularity tells a story, a possible record of environmental stress, tectonic activity, or intelligent alteration. Chemical anomalies in minerals may hint at heat exposure, processing of metals, or fire. Fossilized plant matter may reveal abrupt shifts in vegetation, a signal of resource extraction or environmental modification. Even the subtle composition of soils above rock layers, changes in carbon, nitrogen, or rare elements, can suggest human or pre-human impact. Each layer is a page, each grain of sediment a letter, slowly spelling out narratives that span millions of years. The dual role of rock as preserver and eraser is central to understanding deep-time archaeology. Erosion, metamorphism, and tectonic movement can obliterate entire settlements, leaving only traces detectable through careful isotopic, chemical, or structural analysis. Imagine mountains rising over buried cities, glaciers scouring landscapes, or ocean transgression covering coastal settlements. Rocks, while seemingly inert, are active participants in this process, transforming what was once visible into subtle patterns, whispers detectable only with patient observation. Scientists explore these possibilities with a combination of fieldwork, satellite imagery, geochemistry, and modeling, yet the interpretation remains delicate, often speculative, and always subject to debate. Even the most extraordinary preservation is fragile. Lava flows may entomb structures, yet the intense heat can destroy organic material. Limestone caves may shelter artifacts, but water infiltration slowly dissolves mineral traces. Fossilization captures some forms, ignores others. Rocks are patient but not omniscient. They record, compress, and sometimes mislead. The challenge is to read these layers with care, to separate signal from noise, natural pattern from intelligent trace, while acknowledging the impossibility of certainty in many cases. Scientists continue to debate how effectively subtle geological markers could reveal ancient, non-human civilizations, balancing imagination with rigorous methodology. Picture sliding through the heart of a mountain range, tunnels of stone twisting like veins. The walls are mineral-rich, echoing with the slow pulse of deep earth. In some places you might imagine ancient galleries, carved for shelter, ritual, or resource extraction, now filled with sediment and mineral deposits. Perhaps traces of chemical processing linger in small pockets, altering the isotopic composition of surrounding rock. Tiny fossils embedded in walls may reveal sudden shifts in vegetation, possibly hinting at resource use or environmental stress. Each mark is subtle, each change a possible signature of past activity, patiently preserved by stone yet often hidden in plain sight. Breathe slowly and imagine tracing layers of sedimentary rock with your mind's eye. Visualize the gentle curves of ancient riverbeds, the compaction of mud into shale, the faint intrusion of mineral-rich veins. Sense the slow grinding of tectonics, the patient movement that both preserves and erases. Rocks, in this vision, become storytellers, archivists of energy, life, and perhaps intelligence. Fossils, quarries, tunnels, and intrusions form a mosaic of signals, each whispering possibilities, each offering hints of activity that may have shaped environments in ways now almost imperceptible. Even ordinary stone, seemingly inert and lifeless, holds surprises. Microscopic pores may contain trapped gases or mineral inclusions that record environmental shifts. Strata may reveal chemical gradients hinting at localized heating or resource manipulation. Ancient faults may preserve subtle displacements caused by human-like activity or natural forces. All these traces converge into a layered archive, a geological palimpsest, in which messages of past life and possible civilization remain, waiting for patient observers to discern their faint patterns. Scientists still debate the detectability of such evidence, acknowledging that much may have been irrevocably erased, while recognizing that persistent structures in rock, under the right conditions, may carry information across deep time. As you float above imagined ancient quarries and subterranean networks, picture the duality of rock. It preserves, it hides, it transforms. Fossils capture fleeting moments of life. Sediments encode chemical traces. Quarries and tunnels reflect intelligent alteration. Mountains rise, rivers carve valleys, glaciers scrape surfaces, yet traces survive in subtle chemical, structural, and isotopic signatures. Even as natural forces erase monuments, the story is never completely lost. Patience, sensitivity, and careful interpretation can reveal the whispers of deep-time activity, like hearing faint echoes in a vast canyon. Let your imagination linger over these stone archives, tracing the invisible threads that connect fossils, sediments, quarries, and underground chambers. Visualize the slow accumulation of layers, the subtle shifts in mineral composition, the delicate balance between preservation and decay. The Earth becomes both library and laboratory, a silent teacher offering glimpses into activity that may have occurred millions of years ago. In this meditation, rocks are more than inert matter. They are storytellers, guardians of memory, and subtle recorders of life, intelligence, and the persistent passage of time. In this reflection, breathe slowly and let the mind trace the patterns within stone. Picture layers accumulating over eons, intrusions marking events, fossils capturing fleeting lives, and quarries hinting at purpose. Rocks are patient, enduring, and transformative, holding stories that bridge the gap between natural history and potential ancient intelligence. Scientists continue to debate how much can truly be discerned, but the possibility alone invites wonder, curiosity, and deep contemplation. In the quiet of your mind, drift among these ancient stones, listening to the whispers of time, the echoes of life, and the subtle imprints of activity that endure, even as the surface of the world changes and erases. Close your eyes and imagine the ocean from above, the sunlight fading into shades of teal and cobalt as you drift further from the surface. Waves ripple lazily, reflecting the last glow of a distant sun, while beneath, a realm of quiet, deep, and seemingly endless water stretches into darkness. This is a world largely hidden from our everyday senses, a vast and patient archive where sediments accumulate slowly, layer upon layer, carrying whispers from both the natural world and possibly traces of ancient intelligence. The deep ocean in its stillness is the Earth's quiet memory, a library whose pages are inked in silt, mud, and mineral deposits, and whose shelves extend across millions of square kilometers. Consider the slow fall of particulate matter from above, organic debris, mineral grains, and microscopic life descending like gentle snow through the water column. Each particle carries information: the composition of past oceans, the abundance of life, the occasional anomaly that might hint at forces beyond biology and chemistry alone. Imagine these particles landing softly on the ocean floor, forming sedimentary layers that will endure far longer than any stone monument on land. In oxygen-poor or anoxic environments, where decay is slowed and biological activity minimal, these sediments can preserve delicate structures, chemical anomalies, or even traces of materials introduced by intelligent activity, if such occurred in deep time. Picture a submarine canyon or a deep-sea plain, the landscape shaped by currents, tectonics, and slow deposition. Here, fine layers of mud and silt accumulate at the rate of millimeters per thousand years, silently recording the history of climate, volcanic eruptions, and changes in the chemistry of seawater. Imagine that within these layers, microfossils capture the presence of extinct species, isotopic ratios shift subtly due to unusual energy consumption, and rare elements become concentrated in ways that would be nearly invisible to casual observation. Each layer is a page, a patient recorder of processes and, potentially, of influence exerted by long-gone civilizations. Scientists still debate whether such subtle chemical or structural anomalies could reliably indicate pre-human technological activity, emphasizing the mixture of intrigue and uncertainty inherent in this deep-sea investigation. Now envision the peculiar qualities of anoxic sediments. The absence of oxygen limits decomposition, slowing the transformation of organic matter into carbon dioxide and other byproducts. Delicate structures, from plankton shells to plant fragments, may remain intact for millennia. Even chemicals introduced artificially could persist longer than on the surface, embedded in clay, mud, or the fine-grained sediment that blankets the deep seafloor. In your mind's eye, drift through these slow-accumulating layers, imagining subtle anomalies, perhaps unusual metal deposits, variations in isotopes, or traces of synthetic materials that have resisted decay, quietly waiting to be discovered by patient future observers. As you descend into imagined trenches and abyssal plains, visualize the interaction of geological and chemical processes that shape preservation. Hydrothermal vents, while violent and transformative locally, deposit minerals that encapsulate and protect surrounding sediments. Subduction zones slowly carry oceanic crust into the mantle, erasing some records but compressing and transforming others into new mineral layers that still carry faint memories of their origins. Even the gentle movement of turbidity currents can bury materials rapidly, isolating them from decay and predation, preserving their chemical fingerprints for potentially millions of years. In this layered, quiet world, preservation is both fragile and enduring, a delicate balance maintained by the patient rhythm of the Earth's oceans. Consider the diversity of sedimentary environments beneath the waves. Continental shelves, deep basins, and abyssal plains each accumulate material at different rates and under different chemical conditions. The slow deposition of clay minerals can trap organic and inorganic particles, while carbonate-rich sediments capture shells and microfossils. Imagine a deep oceanic basin far from sunlight, where a thin layer of fine mud covers the seafloor like a soft blanket. Within this blanket, particles settle slowly, forming discrete layers that encode a record of environmental change, including sudden shifts that might hint at human-like activity. Even without direct evidence of structures or tools, the chemical and isotopic composition of these layers could serve as a subtle fingerprint, whispering faintly to those who know how to listen. Floating along the imagined seafloor, envision tiny organisms, bacteria, archaea, and microplankton, continuing their quiet life, metabolizing minute quantities of organic material. Their activity can alter sediment chemistry, sometimes enhancing preservation in anoxic zones, sometimes masking signals of past activity. Yet anomalies remain. Rare earth metals or unusual isotopic ratios, concentrated by past environmental manipulation, might still be detectable, faint echoes of influence exerted perhaps hundreds of millions of years ago. The ocean's memory is subtle, chemical, and enduring, a testament to processes both natural and possibly intelligent. Scientists remain cautious, debating the interpretability of these signals, but they continue to probe the depths, searching for evidence that could rewrite our understanding of deep-time civilizations. Imagine drifting past hydrothermal vents, black smokers exhaling mineral-rich plumes into the ocean. Surrounding sediments capture unique chemical environments, sometimes concentrating metals and isotopes in ways that persist far longer than surface deposits. Perhaps these deposits record natural anomalies, volcanic events, or, in a speculative sense, traces of intelligent activity. Even the most delicate microplastics or synthetic compounds could survive in cold, anoxic layers, slowly sinking to the bottom, embedding in fine-grained sediments, awaiting discovery. Each particle, each mineral grain, is a note in a vast symphony of history, resonating with the rhythms of deep time. Now picture subduction zones at the edges of continents, slowly consuming the ocean floor, carrying sediments down into the mantle. Here, evidence may be transformed beyond recognition, but not entirely erased. Chemical anomalies may be preserved in altered mineral phases, carbon isotopes might be subtly shifted, and trace metals redistributed in ways that preserve a faint fingerprint of past processes. Even the act of erosion, transport, and burial contributes to a layered record, a complex palimpsest that requires patience, skill, and imagination to interpret. Scientists continue to debate the likelihood of detecting traces of ancient industrial activity in such settings, but the exploration itself opens the mind to the profound persistence of subtle evidence. As you float through these imagined undersea archives, picture each sediment layer as a delicate page in a vast book, written in silt, clay, and mineral grains. Fossils provide occasional illustrations. Isotopes trace invisible lines of energy and carbon flow. Rare elements hint at extraordinary processes. Perhaps microplastics, if they existed in the distant past, could persist, their tiny forms embedded like punctuation marks in the narrative of the deep. The ocean is patient, slow, and immense, preserving fragments of memory while erasing others. It is both archivist and editor, recording and selectively hiding, offering glimpses of possibility while leaving gaps for imagination to fill. Visualize yourself drifting past ancient continental shelves now submerged, the slow accumulation of sediments covering any evidence of past activity. Picture deep basins where oxygen is scarce, where organic matter resists decay, and where chemical anomalies could endure for millions of years. Let the mind linger on the possibilities, a trace of metal concentrated unusually, a slight isotopic deviation, a subtle layer of unusual sediment. These whispers, so faint, may hint at purposeful action, environmental manipulation, or industrial activity long vanished. Scientists remain cautious. Interpreting such signals is fraught with uncertainty, but the exploration itself is a meditation on time, preservation, and the delicate traces civilizations may leave behind. Drifting further, imagine the interplay of tectonics, currents, and sedimentation creating both preservation and obfuscation. Submarine canyons funnel sediments, landslides bury material rapidly, hydrothermal fluids deposit minerals. In each case, the ocean shapes the story, sometimes enhancing preservation, sometimes erasing it. Yet, in the quiet, slow-moving layers, traces endure. Carbon isotopes shift subtly. Rare metals concentrate. Microfossils remain intact. Each is a note in the vast, silent symphony of the deep. Scientists debate how these signals might be distinguished from natural variations, but the ocean, patient and persistent, holds them faithfully, awaiting discovery. Breathe slowly and imagine descending deeper still, through the darkness of the abyss, past hydrothermal vents, over sediment plains and through submarine canyons. Each layer is a record, each grain a messenger. Fossils, isotopes, chemical anomalies, and rare elements form a delicate archive, patiently waiting to be interpreted. In this meditation, the ocean becomes a silent library, preserving memories of life, energy, and possibly intelligence across immense spans of time. Even as currents, pressure, and geochemistry alter and transform these sediments, faint whispers endure, testifying to the resilience of subtle traces against the relentless flow of deep time. In the deep, quiet archives of the ocean, civilization may leave its softest echoes, recorded not in monuments but in chemistry, sediment, and isotopic patterns. Even when all surface evidence has vanished, these silent layers endure, awaiting patient minds to detect their faint signals. Scientists continue to debate the feasibility of identifying such traces, but the very possibility invites reflection, imagination, and a profound appreciation for the endurance of memory beneath the waves. Let your mind drift gently through these deep-sea landscapes, inhaling the slow rhythm of sedimentation, the delicate preservation of chemical and biological markers, and the subtle traces of activity that may linger quietly, patiently for millions of years. Drift slowly across the vast expanses of the world's deserts, where the sun stretches its golden fingers across dunes and rocky plains. In this quiet, open space, time seems to move differently, measured not in minutes or hours, but in shifting sands, wind-carved rocks, and the slow dance of temperature between scorching day and freezing night. Deserts, with their extreme dryness and stark landscapes, are among the planet's most patient archivists, capable of preserving traces of human activity, natural phenomena, and perhaps even the faintest hints of civilizations long vanished. Imagine a world where structures built thousands or tens of thousands of years ago remain, partially shielded from decay by the arid climate, each stone and artifact a message to the distant future. Consider the way sand behaves, both fluid and solid, shaping the landscape in subtle, persistent movements. Each dune shifts gradually, sculpted by wind and gravity, sometimes revealing ancient ruins or fossils previously hidden beneath layers of silt. Picture a fragile pottery fragment half buried in a dune, slowly uncovered by the shifting sands, its surface etched by wind and time, yet still holding clues about the people who once touched it. Even in the absence of written records, deserts can act as slow-moving museums, where time itself becomes a preservative. In extreme dryness, biological decay is remarkably slow. Organic material, wood, textiles, papyrus, or leather, can endure far longer than in more humid climates. Imagine ancient garments, carefully folded or draped, surviving beneath layers of sand for millennia. The lack of moisture prevents the proliferation of bacteria and fungi, allowing these objects to remain surprisingly intact. Seeds trapped within soil or rock crevices may lie dormant for thousands of years, ready to germinate when conditions change. The desert is both a destroyer and a conservator, relentlessly stripping away what is exposed yet quietly sheltering the fragments it embraces. Imagine walking past sun-baked ruins, walls of mud brick or stone standing starkly against the horizon. In the dry heat, plaster and mortar harden, forming natural protective coatings. In some places, paint or carvings may persist, their colors faded but their forms enduring, telling stories of lives long past. Wind and sand abrade surfaces gently yet steadily, sculpting patterns that are both natural and historically resonant. Every grain of sand that moves across these surfaces is like a brushstroke, adding texture, erasing detail, yet preserving the essence of the structure. Scientists continue to debate how reliably these features can be interpreted as evidence of ancient civilizations, but the desert's capacity to preserve, even partially, is extraordinary. Consider also the geological and chemical stability of desert sediments. The arid climate minimizes water-driven erosion and chemical alteration, allowing stone tools, ceramics, and even metallic artifacts to persist for millennia. In some ancient riverbeds, dried lake basins, or salt flats, sediment layers accumulate very slowly, providing a stratigraphic record of both environmental changes and potential human activity. Trace elements, isotopic anomalies, and chemical residues can be preserved far longer than in wetter regions, acting as silent witnesses to the passage of time. Even the most delicate chemical signatures may endure, tucked away within fine-grained sediments, waiting for discovery by attentive researchers. Drift over imagined deserts where occasional windstorms shift sand in vast waves, exposing previously hidden artifacts and structures. Picture an abandoned settlement revealed suddenly, as if the desert itself were an archaeologist, gently uncovering the past for those patient enough to notice. Fossilized plant remains, traces of ancient irrigation systems, and impressions of footprints may survive in these arid conditions, offering tantalizing hints of how life adapted to scarcity, ingenuity, and resourcefulness. The desert, in its silent patience, preserves stories that might otherwise have been erased by the more active, water-driven processes of other environments. Even in the most inhospitable deserts, certain microclimates contribute to extraordinary preservation. Rock shelters, shaded canyon walls, and deep crevices provide protection from wind, sun, and sand abrasion. In these niches, organic material can endure for millennia, and chemical residues remain less disturbed. Imagine a fragment of woven fabric preserved in a cliffside alcove, or a series of stone tools carefully laid in shallow depressions, untouched for thousands of years. Each of these remnants is a message, a quiet note from the past, carried forward by the desert's unique ability to shield and conserve. Scientists remain intrigued by how chemical, physical, and biological factors interact in these environments, debating which conditions are most likely to yield detectable traces of long-lost civilizations. Now envision a vast expanse of sand stretching to the horizon, punctuated by isolated rock formations that have resisted erosion. Here, even subtle depressions in the terrain can hint at former structures, pathways, or water management systems. Tiny traces of human activity, fire pits, hearths, or storage pits, may survive, their outlines faint yet discernible to careful observation. The combination of wind, temperature fluctuations, and chemical stability preserves these subtle imprints in a way that seems almost miraculous. Deserts, often perceived as barren, are in fact meticulous curators of history, recording the passage of life with extraordinary fidelity. Consider the phenomenon of desert varnish, a thin dark coating of manganese and iron oxides that slowly accumulates on exposed rock surfaces over millennia. This natural process can preserve petroglyphs, carvings, or inscriptions, rendering them legible far longer than would otherwise be possible. Imagine ancient symbols etched into stone, their presence amplified by the desert's protective varnish, holding stories of people, animals, and celestial events. Even microscopic chemical deposits can persist, preserving the faint traces of fires, metallurgy, or other transformative processes. Scientists still debate how much such evidence can reliably indicate intelligent activity, but the preservation potential is undeniable and compelling. Floating over imagined dunes, picture the interplay of erosion and deposition. Sand shifts constantly, uncovering some artifacts while burying others. The desert's rhythm is slow yet persistent, a gentle reminder that time in extreme environments operates differently, sometimes compressing, sometimes expanding memory. Even ephemeral structures, brush shelters, tents, or ephemeral roads, can leave subtle imprints detectable through satellite imagery or ground surveys. The combination of aridity, temperature extremes, and chemical stability forms a natural time capsule, capturing fragments of history that might otherwise vanish in wetter or more biologically active regions. Imagine now the way human ingenuity might have interacted with these extreme landscapes. Settlements near oases, trade routes marked by stone cairns, or subterranean water storage systems may persist in subtle ways. Mud brick walls may harden into enduring forms, clay artifacts resist decay, and chemical residues accumulate in soils and sediments. Each trace, no matter how faint, is a whisper from a distant past, preserved by the desert's patience. The challenge lies in detecting and interpreting these signals amidst the vastness of sand and stone, a task that requires both imagination and meticulous observation. Scientists continue to explore these environments, debating which features represent natural phenomena and which may hint at intentional design, yet the possibilities inspire wonder and reflection. Even the smallest details can endure. Seeds trapped in dried mud, fibers embedded in stone shelters, or minute chemical residues in ancient hearths all tell a story of adaptation, survival, and potential ingenuity. The desert, harsh yet stable, allows these fragments to survive far longer than they could in more dynamic environments. Imagine tracing these subtle clues with your mind's eye, drifting over dunes, cliffs, and dry lake beds, sensing the passage of time recorded in sand, stone, and the faintest chemical signatures. As you float over imagined desert landscapes, picture the slow erosion of sandstone cliffs, the delicate layering of silt and dried riverbeds, and the protective niches carved by wind and sun. Each layer preserves echoes of life, energy, and possibly intelligence, patiently awaiting discovery. Even when surface traces vanish, chemical and physical evidence may remain, subtle yet detectable to those trained to interpret it. The desert is both storyteller and archivist, quietly holding the past in its grasp, a patient custodian of memory across millennia. Scientists continue to debate the interpretability of some signals, but the preservation potential of extreme aridity is indisputable. In this meditation, breathe slowly and imagine drifting over dunes and rock formations, noticing the interplay of wind, sun, and temperature. Picture ancient structures partially buried, fragments of tools and pottery, and faint chemical residues in sediments. The desert, in its patient silence, preserves the delicate threads of history, a time capsule waiting for careful exploration. Even as sand shifts and sun bleaches the landscape, traces endure, bridging the gap between past and present, memory and imagination. Let your mind linger on the gentle persistence of these environments, where life and intelligence have left subtle marks, quietly recorded in stone, sand, and dust. The desert reminds us that time is both destructive and preservative. While moisture, vegetation, and biological activity erase many signs of past life elsewhere, here in the arid expanse, fragments endure. Walls, tools, organic matter, and chemical traces all persist, forming a layered archive of history written in sand, stone, and subtle residues. Scientists remain fascinated by these environments, debating how much information can truly be extracted, yet the potential to glimpse lost worlds is extraordinary. As you float over these imagined landscapes, allow yourself to sense the quiet patience of the desert, holding secrets across millennia, silently preserving the echoes of life, civilization, and creativity. Breathe deeply, letting the vast arid landscapes fill your imagination. Picture the slow, almost imperceptible shifts of sand, the enduring rock formations, and the gentle preservation of fragile traces. The desert is a time capsule, a patient archivist, a silent guardian of history. Even in its emptiness, it holds memory, offering subtle hints of life and activity that have passed into the deep layers of time. Let your mind drift gently over dunes, cliffs, and ancient riverbeds, sensing the quiet endurance of memory preserved by the desert's arid embrace. Close your eyes and drift to the farthest reaches of the poles, where the sunlight glints off endless expanses of ice, stretching toward horizons that feel eternal. Here the world is slow, vast, and almost sacred, a place where time itself seems to pause, measured in the gradual flow of glaciers and the quiet growth of ice sheets. The ice is a patient guardian, a frozen chronicle that preserves remnants of life, of the environment, and perhaps, if we imagine, traces of civilizations long gone. Yet within its silent beauty lies contradiction, for ice can protect and erase with equal force, its movements capable of preserving delicate structures while crushing, dragging, and reshaping everything in its path. Imagine standing atop a vast glacier, feeling the icy wind brushing your face, listening to the distant groans and cracks as the ice slowly shifts. Each movement is a note in the symphony of deep time, a testament to the patient, persistent, and sometimes destructive power of frozen water. Beneath your feet, layers of snow have compressed over centuries into glacial ice, capturing air bubbles, pollen grains, volcanic ash, and traces of chemical change. These layers are nature's archive, capable of preserving delicate evidence that might never survive in warmer climates. Seeds, feathers, pollen, and even fragments of human-made materials can endure for thousands of years, trapped in a crystalline embrace, shielded from decay and microbial attack. Visualize a small artifact, perhaps a wooden tool or a fragment of textile, buried under centuries of snowfall and compression. The ice preserves its shape, its chemical integrity, and even microscopic details, protecting it from the ravages of water, wind, and biological decay. In this frozen state, time seems suspended. A moment captured and held, a fragment of history locked in crystalline stillness. Scientists study ice cores extracted from these vast sheets, tracing climate, atmospheric composition, and even traces of past human activity. Yet the interpretation of anomalies, subtle chemical variations, rare elements, or microplastics embedded within ice, is an ongoing debate. Could these frozen records hint at industrial activity before our known civilizations? The possibility is tantalizing, but scientific caution prevails, reminding us that ice is both a preserver and a deceiver. Now drift further, imagining glaciers slowly advancing across valleys, carving mountains and crushing all in their path. Here lies the paradox. While ice can preserve, it can also destroy. Entire landscapes can be transformed, artifacts pulverized, and structures flattened under the immense weight and movement of ice. Imagine a cityscape once vibrant, now swallowed beneath kilometers of ice, its remnants compressed into shapes barely recognizable. The ice, indifferent yet majestic, reshapes history even as it guards it, a contradictory custodian that both reveals and conceals. This duality is central to understanding polar preservation. Glaciers and ice sheets are archives, yet they are also agents of erasure. Consider the subtle chemistry within ice. Oxygen isotopes, trapped air bubbles, and dissolved gases form a chemical diary, encoding information about temperature, atmospheric composition, and environmental change over millennia. These frozen pages record volcanic eruptions, solar activity, and shifts in greenhouse gases. In some layers, chemical anomalies could hint at unusual activity, perhaps from human or other technological sources, long before we thought such activity possible. Even microplastics have been found embedded deep in ice, showing how small particles can survive extreme conditions. Scientists debate whether older anomalies, if found, could be interpreted as signs of pre-human industrial activity. The ice preserves possibilities, yet leaves much to interpretation, a delicate balance between evidence and imagination. Picture now the polar landscapes, where crevasses split like silent chasms, and ice cliffs rise like the walls of ancient fortresses. Each fracture tells a story of movement, pressure, and transformation. Within these frozen corridors, organic material may survive, yet is often fragmented or displaced. Pollen grains, fungal spores, and microscopic life continue to persist in suspended animation. Chemical traces of metals, combustion, or altered isotopic ratios may be locked within the ice. In this quiet, frozen world, history is simultaneously protected and threatened, a fragile balance maintained by the slow, inexorable rhythm of glacial flow. Imagine drifting through the Greenland ice sheet, over an expanse where meters of compressed snow hide centuries of environmental memory. Here, an ancient tool buried beneath layers of ice could survive intact, its surface unweathered and its structure preserved. Yet a sudden glacial calving event, a crack that opens and shifts a massive block of ice, could fragment or displace it entirely. The ice is patient, but it is not passive. It moves, breathes, and transforms, shaping the preservation of the past as it sculpts the present landscape. Scientists continue to study these processes, seeking to understand the complex interplay between ice preservation and destruction, and to determine how much evidence of prior activity might truly survive the passage of glacial time. Now envision Antarctica, where the ice sheet stretches across the continent like a vast frozen ocean. Here, environmental stability and extreme cold provide unparalleled preservation potential. Organic remains, trapped beneath deep snow and ice for tens of thousands of years, remain remarkably intact. Microbial life, chemical signatures, and isotopic ratios endure, offering a window into a world largely untouched by external decay. Yet even here the ice moves, slowly but inexorably reshaping landscapes, subducting layers, and erasing structures with an indifferent majesty. The contrast is striking. Ice as guardian, ice as betrayer, a duality written into the very fabric of polar landscapes. Consider also the phenomenon of ice core anomalies, where discrete layers reveal abrupt changes in composition, sometimes corresponding to environmental catastrophes or unusual activity. Could such anomalies be indicators of pre-human influence? Scientists debate the interpretation rigorously. Some argue that unusual chemical signatures may simply result from natural volcanic events, asteroid impacts, or solar fluctuations. Others suggest that subtle isotopic shifts or rare elemental concentrations might hint at industrial or technological processes, long vanished and only faintly detectable. The ice holds these possibilities, quietly preserving them, waiting for patient analysis and cautious interpretation. Picture yourself gliding above crevassed landscapes, each fracture a reminder of ice's dynamic power. Beneath, the weight of centuries compresses and shifts layers, yet within the folds, delicate traces of past life remain intact. Fossilized pollen, tiny fragments of plant material, or chemical signatures of combustion may persist, suspended in a frozen matrix. The ice is selective, preserving some records while obliterating others, teaching us that memory in extreme environments is both precious and partial. Even as glaciers grind and move, subtle anomalies endure, holding a faint whisper of events from epochs long past. Imagine now an ice-covered river valley, where buried structures, tools, or artifacts could lie undisturbed for millennia. The slow flow of ice carries them forward imperceptibly, reshaping and compressing them, yet often leaving key elements intact. Organic remains, chemical anomalies, and isotopic fingerprints can survive far longer than on warmer, wetter continents. Even subtle traces, such as metallic residues or microplastics, may persist in frozen sediments, offering tantalizing hints of activity that may have occurred before human history as we know it. Scientists remain cautious but curious, debating the potential for ice to reveal lost chapters of the past. As you drift above imagined polar landscapes, sense the cold, crystalline air, the brilliant sunlight reflecting off ice ridges, and the slow rhythm of glacial movement. The ice is a paradoxical archivist, both preserving and transforming. Structures can endure, yet shift. Materials can survive, yet fragment. Chemical signatures may persist, yet require careful interpretation. Each layer, each crevasse, each block of compressed snow is a record of time, of movement, and of possibility. The ice teaches patience, reflection, and reverence for the delicate balance between preservation and destruction. Consider subglacial lakes, hidden beneath kilometers of ice, where water remains liquid under immense pressure. Here, microbial life persists in isolation, and sediments accumulate slowly, capturing environmental changes with exquisite fidelity. Could these frozen lakes preserve traces of human or pre-human activity carried from the surface above? Scientists debate this possibility, noting both the rarity of such environments and the extraordinary preservation potential they offer. Imagine exploring such a lake, slowly drifting through its cold, quiet waters, surrounded by sedimentary records that may hold secrets from long before our time. Drift now over ice shelves, where the interaction of ocean and ice further shapes preservation. Calving events can release ancient ice and embedded materials into the sea, while slower accumulation preserves delicate traces within the sheet. Each movement is a negotiation between protection and exposure. Organic remains, chemical residues, and isotopic markers may be released or further buried. The ice is alive in its motion, guarding some records, erasing others, and offering both challenge and opportunity to those who seek to read its quiet pages. Scientists continue to study these processes, acknowledging the debate and uncertainty inherent in interpreting the frozen archive. Finally, imagine gliding through the polar night, the auroras dancing above in ethereal greens and purples, casting a dreamlike glow over the icy expanses. The glaciers, ice sheets, and subglacial lakes extend endlessly, each a silent guardian of history, each a potential betrayer of memory. Organic remains, artifacts, chemical traces, and isotopic signatures are preserved in this frozen realm, enduring against time and decay, yet always subject to the movements and transformations of the ice itself. Scientists debate the reliability and interpretability of these traces, but the frozen world invites reflection, meditation, and imagination. In this quiet vastness, let your mind drift slowly over crevassed valleys, ice ridges, and subglacial mysteries, sensing both the preservation and the erasure, the guardianship and the betrayal of ice. Breathe deeply, letting the cold, crystalline expanse fill your imagination. Picture the layers, the structures, and the chemical whispers preserved in frozen silence. The ice is a patient archivist and a forceful sculptor, holding fragments of history and possibility across millennia. Allow yourself to feel the paradox, the beauty, and the quiet persistence of these frozen landscapes, a reminder that memory endures, even in the most extreme environments, waiting for patient eyes and gentle minds to perceive it. Float gently above the quiet landscapes of Earth, imagining cities, settlements, or industrial zones that may have existed long before our known history. Picture streets lined with structures that gleamed once with metals, copper, iron, bronze, aluminum, catching sunlight and reflecting the ingenuity of their creators. Metals, by their very nature, are both strong and vulnerable. They can last centuries, yet over millennia the patient forces of oxidation, corrosion, and environmental change begin their slow work. The shining traces of human industry gradually fade, leaving behind subtle impressions, chemical residues, and fragments that may barely whisper their presence. Consider a bronze tool left in a field, exposed to wind, rain, and soil. At first, it resists decay, its shape and edges recognizable. But over decades and centuries, the chemical reaction with oxygen, moisture, and soil compounds transforms it. Patina forms, sometimes protective, sometimes porous. Tiny cracks develop, metals flake or dissolve, and over millennia, even these once durable artifacts may vanish entirely. Imagine a world in which every metallic tool, every machine, every structure made of metal slowly disappears, leaving no immediate trace of its former existence. The Earth, in this sense, becomes an efficient archivist, erasing some materials while preserving others under exceptional conditions, like burial in dry caves or entombment in sediments that limit chemical reactions. Visualize iron structures like bridges or supports, slowly rusting in the open air. Water percolates, oxygen reacts, and the very molecules of the metal transform into different compounds, leaving behind reddish residues, crumbling fragments, or nothing perceptible at all. Metals buried underground may fare slightly better, shielded from air and moisture, but even here acidic soils, bacterial activity, and groundwater slowly dissolve them. In deep sediments or ocean floors, some metallic alloys can survive far longer, yet even these can succumb to chemical reactions over tens of thousands of years. The vanishing of metals over geological timescales is almost inevitable, a gentle erasure performed by the patient processes of the planet itself. Imagine drifting over landscapes of imagined non-metal civilizations, where creativity and technology relied on ceramics, stone, glass, or organic materials. Perhaps structures were carved from rock, tools shaped from hardened plant fibers, and vessels molded from clay or resin. In these scenarios, durability relies not on metal, but on material forms that interact differently with their environment. Stone can endure, yet it too can be weathered, eroded, or buried. Ceramics are chemically stable, often surviving millennia, yet fragile to mechanical pressure. Organic-based technologies such as resins, woven fibers, or hardened plant composites may leave chemical or isotopic residues even when the physical objects decay completely. Scientists are fascinated by the possibility of such non-metallic civilizations, though the evidence is subtle, and the interpretations are often contentious. Picture a small ceramic vessel, delicately shaped, surviving under layers of sediment. Its surface is partially worn, yet chemical analysis can reveal traces of pigments, dietary residues, or manufacturing techniques. Even without metals, such artifacts convey stories of human ingenuity, daily life, and cultural expression. Microchemical residues embedded in soils, unusual isotopic ratios, or traces of carbon combustion can act as fingerprints of activity long erased in the physical realm. Scientists remain intrigued by the potential for such non-metal traces to indicate past civilizations, though interpretations are debated, highlighting the challenge of reading history without durable metallic markers. Imagine ancient urban centers built without iron frameworks, relying instead on clay, adobe, stone, and organic composites. The city may have flourished for centuries, its streets bustling, its architecture reflecting ingenuity and skill. Yet today, wind, rain, plant growth, and tectonic activity slowly reclaim the space, covering it with sediment, eroding walls or fragmenting structures. Metallic objects, which might have persisted elsewhere, were minimal or absent, and thus the chemical or physical traces left behind are faint. To detect such civilizations, scientists must search for subtle changes in soil composition, traces of pigments or resins, carbon isotopes, or evidence of organized activity preserved in the environment itself. Even the smallest anomalies, tiny fragments of pottery, unusual concentrations of rare elements, or microscopic wear patterns in sediment, may tell stories lost to conventional archaeology. Drift now across landscapes of imagined settlements that relied primarily on stone and clay. Roads may have been paved with compacted sediments, buildings sculpted from local rock, and tools crafted from stone or hardened resin. Imagine the patient work of wind and rain eroding the surfaces, smoothing rough edges, filling depressions with dust, and slowly blending human-made features into the surrounding landscape. Even in the absence of metals, residues remain. Small chemical anomalies, isotopic shifts, and subtle physical disturbances preserved in sediments. These whispers of activity persist quietly, requiring careful observation and scientific inquiry to detect. Consider the chemistry of metals in these landscapes. Copper alloys exposed to acidic soils gradually leach ions into surrounding sediments. Iron oxidizes into rust, producing localized chemical anomalies. Aluminum may slowly hydrate and flake away. Over millennia, even bronze statues, iron tools, or gold ornaments may leave little more than a trace in isotopic or chemical signatures, detectable only through sensitive techniques. Non-metallic civilizations, by contrast, may leave behind chemical or physical markers that are far more subtle, yet still discernible to careful investigation. Scientists continue to debate how reliable these traces might be in indicating intelligent activity, and whether our interpretations are limited by the materials we expect civilizations to use. Now imagine artifacts embedded in dry sediments or buried beneath riverine deposits, preserved without metals but chemically visible. Organic residues, pigments, and hardened plant fibers may remain, offering clues to diet, technology, and ritual activity. Perhaps delicate patterns on pottery surfaces survived millennia of wind and water, or traces of charcoal from fires mark former hearths. Even subtle shifts in soil chemistry, excess nitrogen, altered carbon ratios, or unusual mineral concentrations, may act as fingerprints of human activity long vanished. Non-metallic materials, in their interaction with sediments, preserve not the shine of metal, but the narrative of life, ingenuity, and environmental impact. Picture an imagined horizon where cities rose without steel frameworks, where transport relied on wheels of wood or resin, where energy was harvested through mechanisms lost to decay. Over millennia, the absence of durable metals results in the slow disappearance of recognizable forms. Yet, faint chemical anomalies in sediments, subtle wear patterns on stone tools, and residues of organic processes provide hints of a sophisticated society. The Earth, in its quiet work of erosion, oxidation, and deposition, selectively preserves and erases, leaving behind a mosaic of clues that require careful reconstruction. Scientists continue to explore how non-metal civilizations might be detected, acknowledging that interpretations remain highly speculative, yet tantalizingly possible. Imagine drifting over ancient quarries, where stone tools were extracted, shaped, and used for construction. No metal frameworks exist, yet the arrangement of stone and ceramic, the distribution of ash and charcoal, and the subtle chemical shifts in soils create a record of past activity. Even if nothing metallic survives, patterns of labor, social organization, and environmental management can sometimes be inferred. Small isotopic anomalies, rare elements concentrated by human activity, and changes in local sediment chemistry act as fingerprints of labor and technology. The search for these subtle traces challenges conventional archaeological methods, yet also expands our imagination of what constitutes civilization. Picture now entire regions sculpted by non-metal technologies, roads compacted from sediments, fortifications carved from rock, vessels hardened from resins and clay. Over centuries, wind, rain, and tectonic activity erode features, yet traces remain in chemical residues, isotopic shifts and microscopic impressions. Even without metal, ingenuity leaves a mark. The planet archives these changes in soil layers, sediment compaction, and subtle chemical fingerprints, waiting for careful exploration. Scientists continue to debate how unambiguous these traces might be as evidence of civilization, yet the potential to uncover lost societies inspires deep curiosity and wonder. Imagine the patient work of time on all human creations. Metals vanish, corrode, or dissolve. Ceramics, stone, and organic composites endure variably, sometimes partially, sometimes with chemical traces only. Even minute anomalies in soils or sediments can hint at former presence, acting as whispers of activity, creativity, and organization. Non-metal civilizations, if they existed, might have left behind these subtle clues, hidden beneath layers of natural processes, patiently awaiting discovery by scientists with imagination, patience, and care. Drift above imagined landscapes where metals have vanished, leaving behind only chemical residues, worn stones, and patterns in sediments. Picture a world where ingenuity relied on non-metallic tools and constructions, where the earth slowly reclaims and erases, yet preserves just enough for those attentive to see. The vanishing of metals does not equate to the vanishing of evidence entirely. Subtle fingerprints remain in soil chemistry, isotopes, and residual structures. The paradox is profound. Even as durable materials disappear, the narrative of intelligence may persist, hidden in the quiet language of Earth's layers. Now imagine floating over the Earth's surface as millennia pass. Metals corrode, oxidize, or dissolve. Organic materials may degrade, yet some chemical traces endure. Ceramics, stone, and hardened resins persist partially, offering fragmented but legible messages of past activity. Subtle isotopic and chemical fingerprints hint at labor, construction, and technological processes. The Earth, patient and impartial, records all, yet erases selectively. Scientists continue to explore, debate, and hypothesize, considering both the known and the possible, weighing evidence that is partial, fragile, and indirect. The story of vanished metals and potential non-metal civilizations invites reflection on time, preservation, and the ephemeral yet enduring marks of ingenuity. Breathe deeply, drifting over imagined landscapes where metals have faded into whispers, yet creativity, ingenuity, and traces of activity persist in subtle chemical, isotopic, and structural forms. Picture the Earth reclaiming, preserving, and archiving, a patient custodian of time and intelligence. Let your mind wander over the slow disappearance and quiet endurance of human traces, imagining civilizations both metallic and non-metallic, and sensing the paradoxical persistence of memory across millennia. Close your eyes and imagine yourself kneeling gently on the surface of the earth, feeling the subtle textures beneath your fingertips. Soil is more than dirt, it is a living archive, a soft, porous library that has been quietly recording the passage of time for millennia. Each layer, each granule, each microbe contributes to a story far larger than any one human life, capturing traces of ecosystems, climate fluctuations, and perhaps even civilizations we may never fully know. Soil breathes, digests, and transforms, a patient archivist that both preserves and alters, keeping silent records of the past. Visualize the forest floor in early morning, dew sparkling on moss and fallen leaves. As your hand brushes the top layer of soil, imagine countless microscopic organisms stirring beneath, bacteria, fungi, and tiny invertebrates all contributing to the slow, meticulous work of decomposition and chemical transformation. Over centuries, organic material decomposes, nutrients cycle, and subtle isotopic signatures embed themselves in mineral particles. These chemical markers, when carefully studied, reveal patterns of vegetation, agriculture, fire, and human influence. Even traces of fertilizers, ashes from burned settlements, or residues from ancient workshops may linger, captured in a subtle chemical dialogue written into the soil. Now drift over grasslands and imagine pollen, so delicate and small, gently settling into soft sediment, absorbed into the soil over time. Each grain of pollen is like a letter in a vast, invisible manuscript, detailing the types of plants that thrived, the shifts in climate, and the subtle interplay between humans and nature. Pollen analysis allows scientists to reconstruct ancient landscapes, to imagine the spread of forests, the expansion of grasslands, or even the presence of cultivated plants long forgotten. In this way, soil preserves a whisper of human activity and ecological change, a quiet testimony that endures far beyond the structures we build above it. Picture ancient agricultural terraces, now overgrown with wild vegetation. The soil in these terraces contains chemical and physical imprints of centuries of cultivation. Elevated nitrogen, traces of charcoal from field clearing, phosphate enrichment from organic waste. Beneath the surface, isotopic ratios of carbon and nitrogen subtly shift, encoding information about diet, land use, and environmental manipulation. Microbial communities adapt to these conditions, leaving behind residues that can persist for millennia, forming a silent biological memory of human interaction with the land. Even in the absence of visible artifacts, the soil retains hints of complex, sustained activity. Scientists debate the interpretive limits of these records, acknowledging that while patterns are suggestive, absolute certainty is rarely achievable. Imagine now a river valley where sediments have accumulated over thousands of years. Layers of soil carry alternating traces of flood events, volcanic ash deposits, and human occupation. The chemistry changes subtly with each layer, capturing variations in temperature, rainfall, and vegetation. Microscopic plant remains, insect chitin, fungal spores, and microbial byproducts all become embedded in these sediments, forming a stratified archive of life and activity. Here, soil functions as a dynamic palimpsest, recording natural events and potential anthropogenic influence, yet its messages are delicate and require careful interpretation. Visualize walking across ancient urban sites, where soil beneath former streets and marketplaces harbors invisible clues. Phosphate enrichment from food waste, microcharcoal from cooking fires, and traces of metals or ceramics leached into the ground may all persist as subtle signals. Microbial communities once interacting with humans continue to leave chemical footprints, transformed by time but not entirely erased. Even the depth and compaction of soil layers can indicate patterns of construction, demolition, or erosion, hinting at the scale and organization of past activity. In this sense, soil is both a memory keeper and a storyteller, quietly encoding traces of life above. Imagine a forest glade in early winter, the soil beneath covered with a thin frost. Beneath this layer, pollen grains from centuries of flowering plants remain suspended, chemical signals of past seasons embedded in mineral particles. Microbial activity continues at a slow pace, decomposing fallen organic material, yet the isotopic and chemical signatures of previous centuries persist. Scientists can extract cores from these soils, reading the layered history like a novel written in invisible ink. Patterns emerge, revealing climatic shifts, vegetation changes, and even hints of human manipulation, such as ancient grazing, burning, or cultivation. Yet interpretation requires caution. Signals are subtle, overlapping, and sometimes ambiguous, leaving room for debate. Now drift to peat bogs, waterlogged and slow to decompose, where organic material accumulates in thick, acidic layers. Here, pollen and plant remnants can survive for tens of thousands of years, creating a high-resolution record of vegetation and climate. Human activity may leave traces in the form of charcoal from fires, fragments of woven materials, or chemical anomalies in nitrogen and carbon ratios. These bogs are natural preservers, maintaining details that are lost elsewhere due to microbial decay or erosion. Yet even here, the interpretation of human influence is subtle, requiring careful comparison with geological and ecological contexts. Scientists remain divided on how far back such traces might indicate complex activity, acknowledging that natural processes can mimic anthropogenic patterns. Picture desert soils, dry and chemically stable, preserving minute traces of plant processing or irrigation. Microfossils of grasses, legumes, and cultivated species may persist, while isotopic shifts in carbon ratios reveal patterns of agricultural management. Even in these harsh environments, chemical residues from human activities, burning, construction, or organic waste, can persist for millennia. Soil in deserts acts as a slow, deliberate archivist, resisting microbial decay and preserving the faint whispers of life and civilization. The signals are subtle, yet they endure, challenging scientists to discern natural variation from the imprint of intelligent activity. Drift now through tropical forests where acidic, highly active soils decompose organic material rapidly, yet layers of sediment beneath rivers and lakes preserve chemical signatures. Carbon isotopes, microcharcoal, and rare element concentrations may hint at human manipulation of the landscape. Pollen analysis reveals changes in vegetation patterns, sometimes consistent with cultivation, deforestation, or fire management. The soil's chemical diary, though partially overwritten by microbial activity and natural processes, still offers insights into historical ecology and potential human influence. Interpretation remains complex and debated, yet the clues endure for patient study. Visualize your hand tracing over soft earth in a glacial valley, feeling the layered texture of deposits laid down over millennia. Embedded within are the fingerprints of life and activity. Microbial byproducts, pollen, isotopic shifts, and sedimentation patterns. Each layer is a page in a silent manuscript, encoding environmental history and possible human influence. Even in places where no structures or artifacts remain, the soil carries subtle signs of intervention, activity, and ecological change. The Earth archives these interactions, preserving evidence that may be detectable through chemistry, biology, and careful observation, yet always leaving room for interpretation and scientific debate. Now drift across river deltas, floodplains, and ancient terraces. Imagine how seasonal floods deposit layers of sediment, mixing chemical signatures and preserving traces of cultivation, diet, or habitation. The soil captures minute changes, acting as a filter, archive, and memory bank. Subtle variations in nitrogen, carbon, phosphates, and rare elements record interactions between humans and the environment, even when the physical artifacts of their presence have long vanished. Microbial communities further encode these traces, contributing to the soil's dynamic record. Scientists debate how clearly such markers can indicate pre-industrial civilizations, yet the potential remains, hidden beneath layers of sediment and time. Imagine a quiet meadow in spring, the soil beneath teeming with unseen life. Microbial networks, chemical residues, and isotopic patterns all contribute to a hidden memory of centuries past. Dust from distant fires, volcanic ash, and pollen from faraway forests settle, layering the soil with additional narratives. Each layer is an archive, preserving the interplay of nature and possibly human influence. The soil is patient, subtle, and persistent, recording without judgment, offering a slow but rich glimpse into the history of the land. Scientists continue to study these layers, debating interpretations, but the soil's silent testimony endures. Finally, picture drifting above the landscapes of Earth in imagined time-lapse. Civilizations rise, flourish, and fade. Metals corrode and vanish, structures erode, but the soil retains whispers of activity, patterns of vegetation, chemical anomalies, and microbial legacies. These silent records, delicate and layered, may hold clues to past civilizations and ecological history long before our documented era. Soil is patient, persistent, and observant, archiving the interplay of life, nature, and human intervention across millennia. Scientists debate, interpret, and hypothesize, yet the Earth's subtle chemical and biological signatures offer a quiet, enduring narrative, waiting for attentive minds to perceive and imagine. Breathe slowly, feeling the soft textures beneath your imagined fingertips, sensing the layered history, the microbial life, the pollen, the chemical fingerprints that endure in silent soil. Let the Earth's patient memory flow through your mind, a slow river of whispers and preserved possibilities, inviting reflection, curiosity, and gentle wonder. Float gently above a landscape of imagined civilizations, ancient cities, or settlements that may have harnessed energy in ways we can scarcely imagine. Imagine faint warmth lingering beneath the surface, subtle traces of fires, kills, or other energy sources imprinted into the earth, whispering across millennia. Energy leaves marks, even when the structures that created it vanish. Heat, chemical residues and isotopic anomalies become the fingerprints of activity, faint yet enduring, like a memory pressed lightly into a soft fabric of time. Picture a valley where ancient furnaces once burned, their fires casting a warm glow on stone walls, shaping metal or producing ceramics. The fires have long since cooled, yet the soil retains chemical memories, thermally altered minerals, subtle shifts in isotopic ratios, traces of combustion embedded in sediment layers. Imagine radiocarbon signatures lingering in charcoal fragments, uranium and thorium isotopes subtly concentrated by human activity, or small pockets of residual heat that change the chemical composition of surrounding materials. These signals may survive for thousands, perhaps tens of thousands of years, quietly encoding the presence of energy use long erased from the surface. Scientists can detect such anomalies, though interpretation remains challenging and in many cases controversial. Now drift over imagined ancient cities, their streets empty, their metal frameworks vanished. Beneath the layers of sediment, subtle thermal anomalies persist, evidence of concentrated human activity. Heat alters minerals, accelerates chemical reactions, and leaves detectable markers for patient observers. Even if the furnaces, workshops, or energy storage devices are gone, the Earth remembers. Thermal imprints are faint but present, a testament to energy once harnessed and released. These subtle cues, when combined with isotopic analysis, may allow scientists to infer the scale and type of energy use, yet the interpretations are often debated, leaving room for imagination and uncertainty. Visualize rivers flowing through these lost civilizations, carrying sediment that captures traces of energy. Charred plant remains, mineral transformations and chemical anomalies settle into the riverbed, preserved under layers of silt and clay. Over millennia, these deposits form a slow, readable record, encoding both natural and anthropogenic influences. The sediments are patient, absorbing and recording, while the water continues to flow above, oblivious to the traces embedded beneath. In this way, rivers act as both archivist and eraser, carrying information downstream, while selectively preserving subtle signs of energy release and industrial activity. Imagine gliding over desert settlements, where ancient fires and energy use once illuminated nights and powered tools. Dry sediments preserve chemical and isotopic markers remarkably well. Heat-altered rocks, concentrated minerals, and microcharcoal provide a silent record of human ingenuity. Even in the absence of metal frameworks or lasting structures, these energetic fingerprints persist, waiting for careful analysis. Yet interpretation is delicate. Natural fires, lightning strikes, or volcanic activity can mimic anthropogenic patterns, and scientists continue to debate how confidently we can attribute these traces to intelligent activity. Picture ancient kilns and workshops, their walls long collapsed, their metals corroded or vanished. Imagine the soil beneath heated repeatedly over centuries, the minerals subtly transformed, isotopic ratios of carbon, nitrogen, or uranium slightly shifted by thermal exposure. The Earth preserves these small anomalies like faint echoes of past energy. Heat, chemical reactions, and subtle isotopic patterns act as witnesses, providing indirect evidence of human activity. In some cases, rare isotopic signatures may hint at unusual energy production methods, hinting at ingenuity we might not yet fully comprehend. Scientists are fascinated by these possibilities, yet remain cautious, acknowledging the speculative nature of interpreting these subtle signals. Drift over imagined coastal settlements, where fires once burned for warmth, cooking, or industry. Sediments bear chemical traces of combustion, rare isotopic anomalies, and localized thermal shifts. Organic residues, charcoal fragments, and mineral alterations remain detectable beneath layers of sediment. Even the absence of visible structures cannot erase these traces completely. Energy leaves an imprint on the environment, subtle but enduring. Microbial activity interacts with these residues, sometimes preserving, sometimes transforming them, adding complexity to the interpretation. Scientists debate how to distinguish natural from anthropogenic thermal effects, yet the traces themselves persist, patient and silent. Now picture ancient forests managed or influenced by human energy use. Controlled burns may have cleared undergrowth, improving agricultural yield or hunting efficiency. These fires leave traces in soils and sediments. Microcharcoal, thermally altered minerals and chemical shifts that persist for millennia. Pollen and isotopic analysis of soils may reveal changes in vegetation corresponding to human activity, indicating a long-term interaction between energy use and environmental modification. Even subtle patterns, once interpreted carefully, can provide glimpses into the relationship between early civilizations and their energetic footprints. Yet uncertainty remains, and scientists continue to debate which patterns are definitively anthropogenic. Imagine the deep ocean floor beneath coastal settlements. Sediments there record both natural and human-induced thermal or chemical anomalies. Fires, kills, and industrial activity contribute minute traces, including isotopic shifts, altered sediment chemistry, and rare elemental concentrations. The slow accumulation of sediments preserves these markers over millennia, yet interpretation is subtle and challenging. Ocean currents, bioturbation, and chemical reactions all complicate the picture, but for careful observers, the traces endure. Scientists remain divided on how clearly these records can reveal past energy use, but the potential for discovery inspires curiosity and methodical investigation. Visualize glacial landscapes where ancient settlements may have existed at the edge of ice sheets. Seasonal thaw and freeze cycles interact with soils and sediments, preserving or altering thermal and chemical traces. Microcharcoal, isotopic shifts, and heat-altered minerals persist in pockets, acting as subtle witnesses to past energy use. Even as ice advances and retreats, reshaping the terrain, some markers remain. Scientists study these environments to understand both natural processes and potential anthropogenic influence, though debates continue regarding the reliability of the signals. Drift now across imagined high-altitude plateaus where energy use may have left ephemeral traces. Fires for warmth, cooking, or industry alter minerals, chemical residues, and isotopic ratios in soils and sediments. Thin air and reduced microbial activity slow the degradation of these signals, allowing some to persist for thousands of years. The traces are subtle but measurable, faint whispers in the chemistry of the earth, waiting for patient study. Interpretation is delicate, as natural processes can mimic human influence, and scientists acknowledge the uncertainties inherent in these analyses. Imagine ancient mines or quarries, where extraction of minerals and energy sources altered the surrounding soils and rocks. Thermal alteration, residual isotopic shifts, and chemical imprints persist subtly, forming a layered record of activity. Even when the physical infrastructure has vanished, the Earth retains these energetic fingerprints. The patient, slow work of geological processes embeds and sometimes preserves these traces, offering clues to the ingenuity and scale of energy utilization. Scientists continue to debate the degree to which such markers definitively indicate human activity, yet the potential remains, encouraging careful observation and experimentation. Visualize an imagined city with kilns, furnaces, and energy-driven processes. As centuries pass, the structures erode, metals corrode, and debris disperses. Yet beneath the surface, heat-altered sediments, isotopic anomalies, and chemical residues remain. These traces act like whispers of energy, subtle but enduring. Even without visible structures, the Earth remembers. Non-metal or early industrial energy use may leave only faint chemical or isotopic evidence, requiring sensitive detection and interpretation. Scientists debate the thresholds of certainty, recognizing the delicate interplay between natural and anthropogenic signals. Drift gently above imagined energy-intensive sites, their heat now dissipated, their fires extinguished. The Earth's sediments record the influence of thermal processes, chemical reactions, and isotopic shifts. Even in the absence of structures, metals, or visible tools, these traces survive in faint, layered archives. Picture ancient combustion altering soils, subtly transforming minerals, and leaving microchemical footprints. The records are fragile yet persistent, patiently awaiting discovery. Scientists remain intrigued and cautious, debating whether these markers represent natural processes or deliberate energy use, yet the potential for uncovering lost civilizations endures. Imagine the patient passage of millennia over all human settlements, industrial or otherwise. Fires cool, metals vanish, structures crumble, yet chemical, isotopic and thermal traces linger in sediments, soils and rocks. The Earth, slow and deliberate, archives these energetic whispers, subtle but persistent. Scientists study these silent records, reconstructing the past with careful observation, experimental analysis and imaginative interpretation. Debates continue, evidence is partial and certainty remains elusive, yet the possibilities are captivating. Energy leaves a mark, even when the tools and fires themselves have long disappeared. Now drift above this imagined Earth, sensing the slow diffusion of heat, the faint isotopic shifts, and the subtle chemical alterations preserved in sediments. Imagine civilizations long vanished, yet leaving traces of energy use encoded in the very fabric of the Earth. Breathe deeply, letting the awareness of these silent, patient records settle in your mind. The Earth archives all, erasing selectively, preserving subtly, and offering glimpses into past ingenuity. Scientists may debate, yet the traces endure, waiting for attentive eyes and thoughtful inquiry to uncover their stories. Picture the patient Earth beneath you, recording heat, chemical changes, and isotopic shifts as faint whispers of lost energy. Even in the absence of metals, structures, or machinery, the planet retains subtle evidence of activity, preserved in soil, sediment, and mineral layers. Imagine tracing these signals with scientific curiosity, uncovering hints of ancient fires, kills, and industrial processes. The narratives are delicate, layered, and open to interpretation. Scientists continue to explore, debate, and hypothesize, yet the faint energetic footprints endure, echoing across millennia, silent but persistent. Breathe slowly, feeling the warmth of past fires, the faint chemical whispers, and the isotopic traces embedded in the Earth. Let the imagination drift over millennia of energy use, over vanished civilizations, over subtle and enduring chemical memories. Sense the paradoxical persistence of energy in the absence of structures, the silent record of human ingenuity patiently preserved. Let the mind wander, reflecting on the delicate balance between creation and erasure, and the patient, quiet voice of the Earth's energetic memory. Imagine a vast landscape of thought and memory, a gentle terrain where ideas once took form, symbols danced in the minds of civilizations, and stories were passed softly from one generation to the next. Language, in all its subtlety and nuance, is fragile. It can endure for centuries in written scripts, but the spoken word, the intonation, the rhythm, and the meaning are ephemeral, evaporating like morning mist across ancient valleys. Words are seeds carried by the wind, yet they may fall on barren ground or vanish before taking root. Non-material cultural heritage, songs, rituals, oral histories, music, gestures, symbolic systems, slips quietly into time, leaving behind whispers that are difficult to trace. Picture an ancient village where storytellers gathered under the stars, recounting events, laws, myths, and lessons through carefully woven oral traditions. Imagine the cadence of voices, the subtle rise and fall of pitch, the pauses that carried meaning, and the communal understanding encoded in shared stories. Generations repeated these tales, yet small shifts occurred with each retelling. A word replaced, a metaphor altered, a rhythm forgotten. Over centuries, entire narratives may dissolve, leaving only hints or fragments embedded in names, place markers, or archaeological residue. The traces are delicate, embedded in social memory and human behavior, rather than in stone or metal. Scientists debate the extent to which oral traditions can preserve information over deep time, acknowledging that much of human knowledge may simply vanish without leaving material evidence. Visualize ancient symbols carved into soft clay, inscribed on bark, or painted on fading walls. Imagine how rain, sun, wind, and the slow decay of organic material slowly erased the signs. Even more enduring symbols, stone inscriptions, monumental reliefs, may be lost to erosion, seismic activity, or human repurposing of materials. The physicality of writing offers some durability, yet the knowledge of interpretation may disappear faster than the medium itself. Non-material aspects of these inscriptions, like cultural context, oral explanations, or traditional usage, often vanish first. Here, the evaporation is twofold. The material can endure, but its meaning may dissolve, leaving silent remnants open to speculation. Now drift across imagined ceremonial grounds, where dances, rituals, and music once communicated complex societal norms and spiritual concepts. Each movement, each chant, each symbolic act is recorded not in stone, but in memory and performance. Over decades and centuries, as practitioners die and knowledge transmission falters, these non-material cultural artifacts fade. Instruments are broken, steps forgotten, chants misremembered. What survives may be mere fragments, echoes of melody, traces of ritual alignment with the seasons, or subtle gestures embedded in remaining architecture. Scientists explore these patterns, studying anthropology, archaeology, and ethnography, yet debate remains on how fully non-material heritage can ever be reconstructed after long intervals. Imagine libraries of knowledge, not bound in paper, but encoded in oral instruction, apprenticeships, and mnemonic devices. Human memory is remarkable, yet inherently fragile. Skills, languages, and complex symbolic systems rely on continuity of practice. If a civilization collapses or disperses, even if other records survive, the knowledge encoded in the minds of its people may vanish. Languages morph or die, symbolic systems become unintelligible, and encoded knowledge slowly dissipates. Across deep time, the evaporation of these intangible signals creates gaps in the historical record that no physical artifact can fully compensate for. Visualize a river flowing through a valley of ideas, carrying away the faintest traces of sound and gesture. Oral traditions are like delicate leaves, drifting downstream, sometimes settling in protected soils or sheltered coves of culture, sometimes dissolving entirely. Microvariations in transmission, subtle changes in pronunciation, meaning, or context, accumulate, eroding fidelity over generations. Even when writing exists, the interpretation may be lost without a living community to decode its symbols. The river of language is relentless. It preserves selectively, erases unpredictably, and constantly reshapes what survives. Scientists examine comparative linguistics and epigraphy to infer past structures, yet certainty remains elusive, leaving room for imagination and debate. Picture the delicate threads of memory in textiles, music, and ceremonial objects. Patterns of weaving, rhythmic structures, and choreographed movements are all repositories of non-material knowledge. As these threads fray, melodies fade, instruments decay, and gestures are forgotten. Even when physical artifacts persist, such as patterned fabrics or stone-carved instruments, the cultural codes they carried may evaporate without the living context. Researchers study residue, where patterns and alignment with astronomical or seasonal cycles to infer usage, yet the interpretations are tentative. The ephemeral nature of non-material heritage reminds us that time is a master editor, removing what is fragile while allowing selective preservation. Now drift over imagined settlements where information was encoded in ephemeral media. Sand drawings, leaf writings, body markings, or smoke signals. Each method is transitory, designed for immediate communication, yet it can reflect complex knowledge and societal organization. Over years, decades, or centuries, these modes vanish, leaving little to no trace. Scholars seek to reconstruct lost systems through environmental clues, comparative studies, or lingering chemical residues, but the gaps are vast and debate is ongoing. The Earth preserves the indirect imprint of activity, trampled paths, soil composition, residue, but the encoded messages themselves may evaporate entirely. Imagine a forest clearing where ceremonial fires once burned, accompanied by chants and rhythmic drumming. Smoke and sound carried symbolic meaning, social cohesion, or spiritual instruction. Over generations, without consistent practice, the knowledge embedded in these ephemeral forms fades. Even subtle auditory and visual cues, so critical for transmission, are lost. The land may retain faint signs, ash layers in soil, trampled ground, or slight depressions marking gathering spots. Yet the meaning, the symbolic language, the encoded knowledge evaporates, leaving only hints. Scientists reconstruct context cautiously, acknowledging the speculative nature of these reconstructions. Visualize deserts and tundras where linguistic and symbolic traditions once flourished, now largely vanished due to environmental pressures and social disruption. Wind and frost erase ephemeral markings, oral traditions fade, and the living memory of people disappears. Yet subtle traces may remain in the arrangement of stones, the chemical composition of soil, or isotopic anomalies from ritual practices. These indirect markers suggest human presence and cultural activity, though they cannot fully convey the richness of lost languages and symbols. Researchers debate whether such evidence can ever reveal the full scope of past cognitive and cultural complexity. Imagine ancient networks of symbolic communication, encoded in architecture, land alignment, or ritualized practices. Over centuries, interpretation fades. Meanings once intuitive become opaque. Patterns may remain, yet the cognitive context is lost, leaving a puzzle for modern observers. Archaeologists and anthropologists infer possible purposes through correlation, analogy, and cautious hypothesis, yet certainty eludes them. Non-material culture, language, music, ritual, is inherently vulnerable to the slow erasure of time, environmental change, and social disruption. Scientists continue to discuss the limits of reconstructing these ephemeral legacies. Picture floating above imagined settlements, hearing faint echoes of spoken words, chants, and music dissolving into the atmosphere. Symbols on clay, wood, or stone slowly fade, altered by weather, erosion, and neglect. Gestures and rituals, once precise, become approximate or vanish entirely. Non-material culture leaves only subtle imprints, patterns in soil, residue on tools, isotopic traces from food processing or ritual activity. Even when tangible artifacts persist, the intangible meanings often evaporate. Scientists debate how to interpret these subtle indicators, yet the potential for insight remains, if approached with patience, imagination, and care. Imagine the passage of centuries over human memory, civilization, and culture. Languages morph, symbols fade, rituals are forgotten, and knowledge slips away like water seeping into the soil. What remains are indirect markers, subtle environmental cues, chemical traces, and physical imprints, which, when combined with imagination and careful scientific analysis, may hint at the richness of vanished intangible culture. The earth, patient and silent, archives fragments, while allowing the evaporation of fragile memory. Scientists debate the limits of inference, yet the whispers endure, patiently waiting to be heard and interpreted. Breathe slowly, letting the awareness of evaporating language, fading symbols, and lost rituals settle around you. Imagine civilizations long vanished, whose spoken words, music, and gestures have largely disappeared, yet left subtle imprints on the earth. Let your mind wander across millennia of fragile, ephemeral knowledge, drifting softly over remnants of human thought, memory, and culture. The earth preserves hints, while time gently erases, and in this delicate interplay, a quiet meditation arises. Reflect on the impermanence of words, the patience of the planet, and the beauty of ephemeral heritage, allowing your mind to rest in wonder and calm. Imagine floating above a vast and quiet earth, gliding gently over landscapes both familiar and imagined, where ancient civilizations may have once thrived, leaving subtle traces that have survived the relentless passage of time. The land itself becomes a quiet archive, holding hints and whispers, a repository of memory patiently preserved in soils, sediments, and rocks. In this tranquil meditation, we seek these faint echoes, subtle imprints that reveal the activity of those who came long before us, or perhaps entirely unknown to history as we know it. Picture the gentle contours of hills, valleys, and riverbeds, each fold of the earth potentially holding minute clues to past human activity. Even in regions where structures have long crumbled or eroded, chemical signatures, isotopic anomalies, and subtle sedimentary patterns persist. The earth is patient, recording heat, pressure, and compositional changes, each layer of soil a page in a book that spans millennia. As you drift over these imagined landscapes, Notice the way light falls on ancient river terraces, how shadows linger in depressions, and how seemingly empty expanses may conceal microscopic evidence of once vibrant communities. Scientists deploy sensitive techniques, geochemical analysis, ground-penetrating radar, satellite imagery and aerial surveys, to detect these delicate markers, yet they caution that interpretations are often tentative, and the signals can be elusive or ambiguous. Visualize a desert plain, where wind has erased footprints and sand dunes shift like gentle waves, covering the remains of structures, paths, and ephemeral settlements. Yet beneath the surface, minute variations in soil composition, traces of mineral extraction, and residues from energy use remain. Sediments may contain isotopic fingerprints or rare earth anomalies that hint at prior industrial or ritual activity. These subtle signals, though faint, are persistent, preserved by the dryness and stability of the desert environment. Archaeologists and geochemists study these layers, combining methods to distinguish natural processes from human activity, yet scientific debate persists, and certainty is often elusive. Imagine gliding above ocean shelves and submerged coastal plains, where rising seas have claimed ancient shorelines. Beneath the waves, sediments quietly preserve traces of habitation, charcoal fragments, thermally altered minerals, isotopic anomalies, and patterns in benthic layers that suggest human influence. Currents and bioturbation complicate detection, yet patient study and sophisticated techniques can reveal hints of past occupation or activity. Visualize the slow, deliberate deposition of sediments, the gentle layering of materials, and the way the earth records energy and matter without haste. Scientists continue to discuss the reliability of these signals and the interpretation of submerged landscapes, but the potential for discovery remains tantalizing. Drift over imagined plains and river valleys, where repeated floods and sedimentation have buried structures, artifacts, and evidence of activity. Even when entire cities are lost to erosion, the earth retains faint imprints. Soil compaction, chemical residue, trace minerals, and isotopic shifts. These subtle signals are like whispers of energy, matter, and human presence, waiting to be interpreted. The landscape itself becomes a guide, its topography hinting at ancient river channels, terraces, and possible settlement sites. Geologists, archaeologists, and remote sensing experts work together, combining physical evidence with analytical models, yet debates continue about how confidently these faint traces can be attributed to intelligent activity. Visualize mountain valleys where ancient mining or quarrying may have taken place, their scars now softened by vegetation and erosion. Beneath the surface, subtle anomalies persist. Heat-altered rocks, isotopic shifts, and traces of human manipulation preserved in the mineral record. Even if surface structures have disappeared, these markers offer indirect evidence of energetic and material activity. Researchers use a combination of geochemical mapping, remote sensing, and field excavation to detect and interpret these faint signatures. The signals are delicate, easily overwhelmed by natural processes, and scientists continue to debate their origin and significance. Imagine the glacial landscapes, where ice advances and retreats, scraping away surface evidence while simultaneously preserving deeper sediments and subglacial features. Within these frozen archives, microcharcoal, isotopic anomalies, and chemical signatures persist, acting as silent witnesses to energy use, settlement, or ritual activity. Each ice sheet and glacier carries a layered record, compressing time into strata of preservation. Scientists probe these icy archives with coring and geochemical techniques, seeking the faint echoes of past civilizations, yet the interpretations remain nuanced and debated. Drift across high plateaus and arid regions, where human activity may have been brief, localized, or specialized. Subtle thermochemical changes, isotopic signatures, and microartifacts persist in soils, sediment layers, and mineral deposits. Over centuries, erosion, wind, and animal activity redistribute these traces, yet careful observation and analysis reveal patterns of energy use, settlement, and environmental manipulation. Even in the absence of standing structures or written records, these subtle cues suggest the presence of intelligent activity, though the evidence is fragmentary and interpretation remains a subject of scientific discussion. Imagine vast forests where human interaction subtly modified ecological systems. Controlled burns, selective harvesting, or ritual plantings. Soil chemistry, pollen composition, and isotopic analysis reveal faint alterations corresponding to human activity. Even when above-ground evidence disappears, these traces remain embedded in the fabric of the earth, whispering clues about energy use, settlement, and cultural practices. Scientists analyze cores, soil layers, and vegetative patterns, piecing together a complex picture of interaction between humans and their environment. Yet interpretation remains tentative, and many details of past activity may remain forever elusive. Visualize coastal plains now submerged, ancient agricultural terraces beneath layers of silt, or estuaries altered by tidal management and sediment deposition. Geochemical and isotopic analyses of sediments can reveal anomalies that suggest human activity. Traces of nutrient enrichment, thermally altered minerals, and microcharcoal deposits. Even subtle variations in sediment structure or composition provide clues, yet distinguishing natural from anthropogenic processes requires careful, interdisciplinary work. Researchers continue to debate the confidence with which such faint echoes can be interpreted as evidence of past civilization. Imagine silent plains where stone tools, kilns, or energy-intensive activities may have existed. The structures have vanished, but chemical and isotopic fingerprints remain in the soils, sediments, and rock matrices. Trace metals, rare earth anomalies, and localized thermal alterations act as subtle witnesses to past human activity. Even small-scale settlements or isolated industrial sites leave detectable signatures when studied carefully. Scientists combine geology, archaeology, and remote sensing to seek these signals, but uncertainty persists. Interpretations require caution, and debate continues regarding the attribution of faint anomalies to intelligent activity. Picture flying over imagined landscapes where non-material evidence intersects with material remnants. Ritual sites, symbolic arrangements, and ephemeral constructions. Soil chemistry, isotopic analysis, and microartifacts provide subtle indicators, while aerial and satellite imagery reveal patterns invisible at ground level. Interdisciplinary collaboration allows researchers to combine data streams, searching for faint echoes of civilization that may have persisted long after structures themselves vanished. Even so, the faintness and ambiguity of these signals leave room for debate, and scientists caution against overinterpretation. Now drift over imagined planetary landscapes where ancient settlements, energy use, and symbolic activity have long disappeared. The Earth retains subtle signatures, chemical, isotopic, thermal, and sedimentary markers that, when interpreted carefully, hint at past activity. Deep time preservation is selective, erasure is constant, and patience is essential for discovery. Scientists continue to study these faint echoes, debating methodology and interpretation, yet the potential to uncover hidden chapters of Earth's history inspires continued exploration. Imagine floating over the landscape at twilight, imagining the faint traces of human activity in every soil layer, sediment stratum, and chemical anomaly. Microcharcoal, isotopic shifts, altered minerals, all these are faint echoes patiently waiting to be interpreted. Scientists combine knowledge from geology, archaeology, and remote sensing to decode these subtle signals, yet uncertainty persists, leaving space for imagination and wonder. Even the absence of direct evidence becomes part of the story, a reflection of Earth's selective memory. Breathe slowly, letting your awareness encompass rivers, deserts, oceans, ice, forests, and mountains, all repositories of faint echoes. Imagine civilizations long vanished, yet leaving subtle traces in chemistry, isotopes, sediments, and topography. Let your mind drift across millennia of patient Earth recording, erasing selectively and preserving quietly. Scientists may debate interpretation, yet the traces endure, whispering stories of energy, settlement, ritual, and ingenuity. In this quiet meditation, imagine the faint echoes settling into your mind, offering reflection, curiosity, and wonder as you drift peacefully over the patient, remembering Earth. Slowly, Allow your mind to drift above the gentle curves of the earth, where mountains rise like silent witnesses, rivers meander lazily through valleys, and deserts stretch endlessly beneath the soft glow of twilight. Imagine the earth breathing beneath you, inhaling the warmth of the sun, exhaling the cool of the night, and quietly remembering all that has come before. Every stone, every sediment layer, every frozen glacier and sun-bleached dune is part of a vast archive, holding fragments of history that may tell stories of civilizations we scarcely know, or perhaps never knew at all. Breathe deeply and picture the subtle chemical shifts in soils, the faint traces of carbon isotopes, microplastics, and rare earth elements that may carry whispers of human activity or even pre-human ingenuity. These tiny signatures, often invisible to the naked eye, are like fingerprints pressed softly into the Earth's memory. Scientists study them with careful attention, yet they remain cautious, aware that interpretations are tentative and open to debate. The Silurian hypothesis reminds us that the planet may harbor evidence of advanced civilizations long vanished, yet these traces are faint, elusive, and easily mistaken for natural variation. Even as we question, even as we hypothesize, the Earth continues its patient work, erasing some marks while preserving others in the slow, unhurried rhythm of geological time. Imagine the deserts, where heat and aridity have preserved fragments of activity for thousands, perhaps tens of thousands of years. The sands shift softly with the wind, sculpting ephemeral dunes that seem almost alive, erasing footprints yet sometimes revealing hidden layers of sediment that carry traces of long-vanished lives. Picture the subtle isotopic anomalies hidden beneath the surface, the slight variations in soil composition that hint at cultivation, controlled fires, or even rituals. Here, the planet is both archivist and editor, selecting which marks to preserve, which to let fade, reminding us that our presence is fragile, fleeting, and often imperceptible in the grand narrative of Earth's deep time. Drift over glaciers and polar ice sheets, thick and ancient, moving with deliberate patience. Ice preserves stories in its layers, locking air bubbles, particles, and isotopic markers like a slow-motion time capsule. Yet ice is also relentless, grinding landscapes beneath it, erasing roads, structures, and traces of energy use with imperceptible friction. Imagine the paradox. The same glaciers that protect some signals can destroy others, creating a delicate tension between preservation and loss. Scientists study ice cores meticulously, analyzing trapped gases, isotopes, and particulates to infer both environmental conditions and possible human or pre-human influence. Even so, debates continue, for interpretations are rarely straightforward, and nature's archive often speaks in whispers that are easy to misread. Let your mind drift to ancient forests, where vegetation has reclaimed areas once cultivated by humans or perhaps by other beings we may never know. Pollen ratios shift subtly, soil chemistry hints at past management, and isotopic markers may suggest energy use, agriculture, or land alteration. The Earth, patient and impartial, records these interactions with quiet precision, yet it does so in a language that requires careful translation. Every fragment of memory is incomplete, every trace a suggestion rather than a certainty. Scientists act as detectives, piecing together stories from these soft signals, aware that gaps are inevitable and some mysteries may remain forever beyond our reach. Now imagine submerged landscapes, coastlines swallowed by rising seas, where river deltas and continental shelves conceal layers of sediment recording faint echoes of human or pre-human presence. Sedimentation here is slow, patient, and precise, embedding fragments of artifacts, chemical shifts, or isotopic anomalies beneath meters of silt. Picture the soft movement of water, the gentle accumulation of layers that may capture energy usage, ritual activity, or settlement patterns. The oceans are patient archivists, preserving what is delicate, but also erasing what cannot withstand submersion. Interpretation is difficult, sometimes controversial, and scientists continue to debate which signals indicate life, civilization, or mere geological happenstance. Take a deep, slow breath, and let your imagination glide across symbolic and non-material legacies. Songs, gestures, rituals, languages, and systems of knowledge are ephemeral, leaving almost no tangible mark. Yet they may subtly alter soils, affect pollen distribution, or shift isotopic signatures in ways detectable to patient eyes and instruments. These intangible echoes remind us that civilization is more than stone and metal. It is pattern, behavior, and energy, fleeting yet powerful. Scientists remain cautious, understanding that evidence is sparse, interpretations uncertain, and much is still open to imagination. The faintest signals may hold truths, yet they demand humility in our assumptions. Picture the Earth as a living, breathing archivist. Mountains record erosional histories, rivers carry chemical traces downstream, deserts preserve anomalies in sediments, ice sheets trap particles, and oceans silently layer their stories in silt and sand. Time itself moves slowly here, folding and compressing, erasing and preserving, like a meticulous editor who decides which words survive in a manuscript spanning eons. Human activity, whether monumental or subtle, interacts with these processes, leaving fragments for careful observers to decode. Scientists piece together this mosaic from chemical, physical, and biological traces, but certainty is rare, and debate is a natural companion to discovery. Now consider the ephemeral nature of civilization in the context of deep time. Buildings crumble, roads vanish, metals corrode, and even the faintest chemical signals can be dispersed or transformed. Energy usage leaves isotopic footprints that persist only under certain conditions, and non-material culture often evaporates entirely. Yet, amidst this impermanence, the Earth continues to whisper. Each sediment layer, each pollen grain, each ice core holds a fragment of memory. The planet does not judge, it archives patiently, impartially, and silently, offering glimpses of what was without comment or ceremony. Imagine your mind drifting gently across these subtle signals, observing the interplay of preservation and loss. Reflect on the paradox. Human civilizations are impactful yet often transient. Our technologies and cultures may vanish almost completely over geological timescales, yet the Earth endures, recording, transforming, and gently reshaping all. Picture the planet's memory as a vast, layered tapestry, threads of energy, matter, and life interwoven over millennia, some bright, some faint, some nearly invisible, yet all contributing to the story of the Earth. Take another slow breath and visualize the planet's patient, impartial processes. Erosion, sedimentation, chemical alteration, biological succession, glacial movement, and oceanic deposition. Each process contributes to the erasure or preservation of human and pre-human activity. Imagine the debates among scientists who study these phenomena, carefully weighing evidence, forming hypotheses, acknowledging uncertainty. The Silurian hypothesis, carbon isotope anomalies, microplastics, isotopic traces of energy use, non-material cultural markers. All are threads in this intricate fabric, each a clue, each a whisper, each a subject of careful scrutiny and ongoing debate. Allow your imagination to rest over deserts, ice sheets, oceans, and forests, considering the subtle balance of impermanence and endurance. Ask yourself softly, if humans disappeared today, what would remain? How would Earth remember us? Would faint chemical anomalies speak of our presence? Would altered soils, sediment layers, or isotopic signatures survive to hint at our existence? Would our non-material legacies, songs, rituals, gestures, leave any trace at all? The Earth does not answer directly, it continues its patient work, whispering through the medium of time, preserving selectively, erasing impartially, and leaving us to wonder. Slowly close your eyes. Breathe gently. Feel your awareness expand over rivers, mountains, deserts, ice, forests, and oceans. Imagine civilizations rising and fading, their chemical, isotopic, and structural traces subtly woven into the fabric of the planet. Sense the passage of eons, the rhythm of preservation and loss, the quiet persistence of Earth's memory. Let the paradox settle in. We are transient yet part of a continuum, fleeting yet capable of leaving whispers in the planet's archive. Feel your heartbeat align with the slow, deliberate pulse of the Earth, its patient breathing, its silent recording, its gentle reshaping of all that passes across it. Drift in this awareness, letting wonder, humility, and curiosity fill your mind. Allow the Earth's whispers to soothe you, and let the vastness of time and memory lull you into calm reflection. Good night, traveler of time. The earth remembers and whispers, and you are part of its enduring story.